it's so freaking amazing for me. First of all, the kid, I don't know why he's not perpetuated to fame at this stage of the game, but he works on his own rules. But he's got some amazing music, and he talks a lot about that in his music, which Chris Brochu is an amazing artist. I don't know why I bring him up, except that he's my nephew and he freaking sings. He's got some amazing stuff.
Promotion.
Well,
oh, check it out.
Going back to Mark growing food and stuff, it reminds me of when I used to be in the movement. I'm not anymore, but I used to be like a serious leftist back when leftists used to actually care about, people of color in poor communities and, poor people being treated like crap by their landlords, and back when you actually did community organizing. I don't even know what the left is anymore, but that was years ago. But one thing I did learn from the movement was that everybody can plug in the way that they should. I remember the organization used to always say, like, okay, not everybody's going to be a Sada Shakur, not everybody in the movement is going to be on a bullhorn, but, we also need people to print flyers and to cook the food and, you know what I'm saying, to open the doors at 9 a.m. And, like, there's so much that goes into a movement. And I think that even in Mark growing your food, you were saying like, oh, like I can't worry about flat earth because I'm like growing food. I actually love that, and I think that's a great point, because I think it still collectively adds to the push for truth, moving farther away from the establishment that's been put here for us, that they want us to just buy into. You know what I'm saying? I think that, growing your own food and flat earth, for example, are, two wings of the same bird, so it's like, yeah, we might not be able to do everything. Like, I'm not growing my own food. I wish I was, but I'm over here thinking about flat earth. And so when people like us come together, we are all collectively a movement of people moving away from the status quo, which I think is the most important thing. So I think everybody plugging in the way that they can is more than enough.
Well said. Nice. It's true.
Well, I'd like to just play a little song on my flute if I can. I want to just play 30 seconds. I want to title the piece Sunday Funday and the Flat Earth Gang.
Let's go, 30 seconds. Hard as fuck. Let's go.
Okay, this is the truth of the earth, and the earth ain't flat.
It was beautiful.
Yeah, it blew my ears out.
Did y'all kick him down?
Yeah, he trolling at that point.
I thought he was saying the word. He was his flute said round, but it was saying flat. Really, he didn't.
It was very flat. It was very flat. What's up, Sydney? How you been, man?
Good, man. I couldn't talk yesterday, but I came to talk about that drawing you had. I don't know if you want to put that back up.
Fantastic, dude. Hell yeah.
I couldn't even, I was doing like two things at once, so I couldn't even really figure it out. But
two birds.
I definitely was like scratching my head.
2 girls, 1 cup. He's getting the picture. We just need a brief flute intermission now. Just like.
Yeah, I guess we could have used that. All right, so there it is. Let me see if you can read it now. It's that small.
PTR, everybody.
Yeah, it should be there.
Yeah, so what do we have here?
I'll explain what happened so you can read it. I used argon gas. It could be any. The gas needs to be, figured out a little bit better. We just need something that floats with this supposed Earth's gravity. We're theorizing that Earth's gravity is real in this scientific experiment. So we're going to use a gas that is like I don't know what the term is, but just kind of it floats equally. Like it finds its equilibrium. It doesn't go up. It doesn't fall down like H2S and stuff like that. I don't know. I'm not a gas guy, so we need to find a gas that will do that. We pump it into a atmospheric chamber, which means it's a vacuum chamber, but it's just you can change the atmosphere. I figured that would be better wording for it. change the atmosphere. So we zero atmosphere. We pump in this gas. That material is osmium, something like that. It's the heaviest shit we could find on Earth. It's 2,000 tons of it in this arrangement here. I got that. I think we can do that because I found 1 million 1 million pounds weight. That's verified. So I got to do some calculations. I think with this material and about a NASA vacuum chamber size thing, I think we could fit this ball in there. And I think it would be around 2,000 tons worth of the shit. I believe that is enough force, bending of space-time, to attract a gas layer to it. Since the gas is very, very easy to manipulate, this thing would, and Cavendish shows that there is a force of a bending of space-time with even the most tiniest little nylon spheres that you can put on a professor's desk, right? So they have a very small force there. So 2,000 tons in such a small mass or such a small area in a vacuum chamber, it should theoretically develop a layer. Would you agree?
A layer of
gas that you have pumped into.
Like, you're saying so. Okay, I was looking at this wrong. This is why yesterday I was kind of triggered, but I was working.
Tell me what you thought, just so I can fix it.
Yeah, give me like a side mission. I'll tell you what I thought. What I thought I was looking at was like some kind of like subsection of some kind of like larger space. Like the cube was like the subsection cut out of some larger space, and that space was argon gas, and there's a 2,000-ton ball floating in the gas. But what I think it is that you're saying now is you're just saying this is a vacuum chamber with argon gas in it, and we got a super heavy weight in the room.
Yes, sir.
Suspended, it could be hanging on a fucking wire or whatever. You're not saying it's like floating on top of the gas.
No, there could be a wire holding this.
Yeah, okay, that makes more sense.
Theoretically,
you're just
the
saying
ball
you should see the argon start collecting on the surface of that 2,000-ton ball.
Yes, sir, because of the bending of the space-time caused by the ball, right?
That's interesting. I mean, it doesn't sound ridiculous to me at all.
Fantastic. I really value your opinion on that.
Nice.
I know you're a smart guy, so that's excellent, man. I if you find anything, you know what I need? I need the gas. Because I put argon because, I just thinking we can stimulate it somehow and then be like, boom, there's a fucking layer of gas on this ball, You can see it. But more importantly would be the molecules, are, how would you say that? It's not going up or down. It's just says like it's stationary. Not stationary. That's a bad word for it too. If it has found its equilibrium. You ever seen like a balloon that's just the right amount of helium and air in it, where it just is paused right in a stale air room? It's just hanging out in the middle of the room.
Yeah.
Yeah, that's what I kind of need to find a gas that does that in this box, if you know any.
Well, like anything, you could equalize like anything to make it fly. Just like you could make a submarine float at any depth, just by pumping water in and out of the tanks. So, like, you could equalize anything. I don't know. I'm not sure if I understand what you're saying, but
do you know how significant that would be if we was able to do this and see that layer of gas? That literally, I mean, you can ground that. You can ground that straight to a piece of copper going straight into the fucking earth. You can ground that. You can ground the shit out of that. It's the mass that we're worried about. And if it is forming a layer of gas on that, that's undeniably gravity at that point, isn't it? And that would be better than the Cavendish experiment by far.
That's what I can't determine. I can't even determine if your experiment is valid. I'm just saying, off the face of it, looking at that picture, with my conception of how things work, that picture follows. So I would imagine if you did it in real life, it would follow. But I don't know. Like, I'm not a scientist, so I don't know how valid, the experiment would be. I definitely I think it's interesting though. Like, I think it'd be like, there's like a lot of other factors. Like, how would you like view the argon? Actually observing the results sounds like it would be problematic. I don't know how that would occur, but like, if you could view the argon, like, like if you can make it glow or something, like you could like charge it up, and if argon is like one of the noble gases, like neon or something, right? Like, which I think it is. You like electrify the chamber, and the argon gas glows more around the ball. Like, maybe that'd be a way. I don't know.
That's
I
what
don't know
I
how
was
valid
thinking when
that
I
is,
thought
but
that up.
it sounds plausible. It doesn't sound ridiculous at all.
Okay, so here's the question though: like, why? Would you agree that no one has done this?
I have no idea.
No, you would agree, like, if somebody has done this, you would have an idea for sure.
No, I mean, because I would presuppose that I'm like aware of every experiment that's been done, which I'm not. I don't claim to be.
Well, I'm pretty sure all this argument we've been doing, nobody's ever brought that up and been like, "Look at this."
I'll say that I've never heard it brought up. I'll say that I've never heard it brought up in any room on Clubhouse.
Okay. Have you ever, like, check this out? This answer is where's your gas without a container? That literally, there's gas without a container, even though you're in that box is just simulating.
So to me, this is like a larger. It's not necessarily a problem, but I'll just go ahead and say it's like a larger problem where there's like a bar that seems to be set for experimentation. Where, like, for instance, you have the Cavendish experiment, which has been done and refined. So like nowadays, like, they don't even do Cavendish because there's like better versions of Cavendish that are like modern and like way more accurate, way more like useful. So it's only like been refined and gotten better. So like science as a whole, I don't know if this test exists or not. So I'm not going to say whether they think they needed it or not. But it's like you've come up with another test and you're saying like this test would prove it. But it's like there's so many other tests that we say proved it. Like, why does this test all of a sudden like prove it? Like, this is like the bar that seems to be set is like it has to be this experiment. There's like I get this a lot, like with the refraction. Like, there's so many experiments that show exactly how refraction indexes work, exactly how light bends under specific refraction conditions. It's testable in a lab. But you guys come up with an experiment that like, or all the experiments, you guys try to find a way that shows that all these predictable refraction experiments don't apply. Like, you guys phrase it like bringing something up over a curve and act like refraction doesn't completely describe everything that's happening when light's bending. You come up with these ridiculous bars for experiments. So the experiment you guys come up with in the refraction instance is you want to see it done over a 25-mile or 30-mile distance. This is like an impossible experiment. We can do it in a lab over short distances. We can like manipulate refraction indexes to build complex optics and like precise optical equipment, right? But like, you guys produce this ridiculous experiment. And I'm not saying your experiment is ridiculous at all. I'm just saying it's just like a new bar that you've created. It's like that experiment's not good because it comes from like, I guess, an existing body of knowledge, so you don't trust it. But if there would be like a new experiment, you guys feel like if there's like new experiments that could be done, then you could trust like the new experiment because you thought of the experiment yourself. I don't know. I'm not criticizing. It just seems like an impasse that I see happening a lot is like what I guess I'll call like the impossible experiment paradigm.
Well, the problem I have with Cavendish is, like I said, the professor has one on his desk that works, right? Would you agree? Most people, like, I mean, I've heard even Neil deGrasse Tyson, professor.
Yeah, no, I've heard it colloquially described as Cavendish is something you can do on your desk with like
because I can buy one
a relatively inexpensive experiment. Yeah, I get what you're saying.
Right. That's not grounded, is it?
I see. I don't know. Like I don't know what this desktop Cavendish experiment is. I've
It's
even
a
looked
little
on.
apparatus that you buy.
But so, I've even looked on Amazon.
It
People
starts
say you can
gyrating.
buy-
It
I mean,
starts moving back and
I can
forth.
imagine what it would look like, but people say you can find it on Amazon. I can't seem to find it on Amazon. But I've heard people say there's problems with it, and sometimes it doesn't work. But
you gotta be
like I
improving
said,
all the time with science, right? Would you agree on that?
Experiment. That's
It's not in my experiment. It's the only one. It is the newest one at the moment. This what you're working with Cavendish is like some pretty old stuff. And when you said that
right, that's what I'm saying. It's been like
they always leave the same elements and hide it. Like you think it's been done in a vacuum chamber, but it's actually been done in a sealed
they don't
enclosure.
even do it. They don't even they do molecular Cavendish experiments now. I know you guys don't buy that, but I'm just saying that's how advanced Cavendish has got. Is they literally are doing accelerated ion molecular Cavendish experiments. But before it got there, right, it was less outlandish. But the Cavendish experiment has been refined and redone. They've done it using cesium atomic clocks and high speed. They've done it in so many different ways.
You got a link for your favorite one.
I think the most interesting one is the Hafele Keating experiment, where they basically took some 737 airliners and put some cesium clocks in the airliners and flew them around the world in different directions. And the difference in the relativistic difference in the clocks when they compared them afterwards basically shows you that the Earth had to have been rotating in space. It also proves the inaccuracy of the ether concept at the same time. That's why it's particularly interesting to me.
Is it an analog or a digital?
It's a cesium clock. So clocks work. The concept of a clock is just setting a vibration and measuring it. So a grandfather clock or your average tick-tock clock, right? They have a spring that unloads at a specific rate. So it might unload at 10,000 ticks per minute or 10,000 ticks per hour. Or let's just make it easy. We'll just say 600 ticks per hour. So that's every 10 seconds. There's 60 ticks. So that means, well, okay, that's a bad example. We'll say every tick is a second. There's 60 seconds in a minute. So that's 60 ticks for a minute. And then we'll say there's 60 minutes in an hour. So times that by 60. So that's what? 6 times 6, 360 ticks. So you've got 360 ticks every hour. That's the rate that the spring is unloading. That's how a mechanical clock keeps track of time. Every tick of this mechanical spring, they call it 1 second. So a digital clock works by measuring the vibration of a crystal. The crystal vibrates at a super high rate. That's why it's way more accurate, because it's subdivided into way smaller units. The original clock I described has 360 ticks in an hour. A quartz clock has something 360,000 ticks in a second. Right. Probably higher than that, an astronomically high amount of ticks. That way you get way more accurate timekeeping. A cesium clock uses the vibration of a cesium atom, which vibrates way faster than even a quartz crystal vibrates. So by measuring the vibration of this cesium atom, you're able to subdivide time into a way, 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 way smaller amount. And that gives you a way, way, way more accurate clock. And that's what they use. So they fly these 2 cesium clocks in different directions around the Earth. And they're able to measure at a very, very, very highly accurate rate what the difference in the clocks was. And that has implications with space-time and the whole ether concept. But it also proves that the Earth is spinning in space.
So they are analog
No, they're I guess they're like an advanced. You could call it like an advanced digital.
They're
clock.
mechanical though. They're mechanical.
No, it's an advanced digital clock.
Okay. I'm just wondering if they are susceptible to high air pressures and high electric static fields and stuff like that.
I mean, I don't know. I guess like when it's all ultimately said and done, you could deny like the validity of the instrument as a whole. But I mean, these instruments are highly accurate. They're shielded.
Oh, I don't doubt that.
I
think they might have some issues doing that going into this.
I mean, like, I don't know how the experiment was done. I'm not going to claim to know whether they set it inside a Faraday cage and how they mitigated for interference outside of.
It's not a bad experiment, but let's go further. Why not?
So you could start though. Like a good place to start is to just look up the experiment. And Google the experiment. There's a Wikipedia page on it. I'm sure you can find like.
Yeah, I've read on it. And really, just there's not that much information. It's like they.
Well, you have to. The information is there. You would just have to put in the work to find it. Like,
I've read a couple of things, and all you can get is a couple of pictures of it. And
I just told you about it 5 minutes ago, though. Jason, be real. Come on, let's be real, bro. I just told you about
the
5 minutes ago.
Clocks, and I just wanted to make sure it was what kind of clock it was, because I don't know. I mean, I'm
well, so
sure
if you just Googled
these times.
So Jason, let's just be real. Walk with me.
I know. I'm not expensive.
Just walk with me for a second, please. Just walk with me for a second.
I'm here.
Okay. If you're just looking up a cesium clock, okay, you'd have to look up the type of cesium clock they used in the experiment. In that specific experiment, in order to find that out, you'd have to actually look up the experiment that I mentioned, read about it, and find out information. Look up the references, find the information. Like, you'd actually have to spend more than a couple minutes, like, glancing over some quick Googles in order to find out these answers.
And that's like when people do that?
Because it's frustrating because it's like in a daily life, I'm going on like deep dives and rabbit holes trying to find information. And like, I might have to like learn about some piece of technology. And in the first paragraph, they start talking about shit I have no idea about. So like my first week is just me going on side missions, just trying to understand the first paragraph. And then I can come back to it a week later and like move on to the next step. Right? Like, I don't expect it to be easy. Like, shit is difficult. Like, but it's like the questions you have, like, you have this experiment you just come up with, and it's like, you'd think that you'd be interested in finding out, like, getting really down to the bottom, the nitty gritty of other people who have done similar experiments. I just told you about one. You can find out whether the cesium clocks they used.
This clock experiment.
You can find out if the cesium clocks that they used on the 747s that Hafele and Keating used in their specific experiment, what kind of shielding for interference they used. That information is available.
Well, I had the Flat Earth explain it to me live on a debate. You could check it out on his channel. I asked him the same thing, and he was kind enough to explain exactly. I asked about it could exactly what I asked you. Could it be the atmosphere affecting these things, the pressures, the electromagnetic fields that it's going through? Could this be a problem?
But how do you know if the atmosphere is affecting a thing when you don't even know what the thing is?
That's the question. That is the question. The thing is a watch, dude. The thing is a watch.
Okay, but this is I specifically said that.
Yeah, I know you explained it. I wanted you to explain it. It was a facetious question. I wanted to make sure that everybody knew that it was a watch.
The thing is a cesium clock on a 747. That's what you're claiming could possibly be affected by interference. In order to find out if a cesium clock on a 747 could possibly be affected, first you'd have to find out what kind of clock it was and what kind of protection that they implemented, that they claim to have implemented to protect from interference. Like if I have an experiment that's designed to measure something, but there's a lot of like outside vibration, in my experiment, I have to detail how I'm going to mitigate the outside vibration, the outside interference. So I might design some kind of spring or shock absorbing system into my experiment, and then I would explain that. It's the same thing for Hafele Keating. The question you have, I wonder if this stuff could be affected by outside interference.
Yes.
You can just go out and get the information. It's not being held under lock and key by some cabal.
Yeah, but would they include that information if it's being scientific as
You have
possible?
to actually look.
I'm saying I have looked, dude.
No, you haven't, dude. I bet you have not.
When I literally talked to the
Keating.
fucking guy literally,
I don't know.
documented.
I just mentioned you did not know
It's
what
documented.
Keating
The guy
was
gave
5 minutes ago.
Dude, I asked you you know what a facetious question is?
Wait,
so you knew what Keating was?
Wait, but Sydney, you sat here and explained the entire experiment. He had no problem listening, and then he happened to just it was going very well, and then he had a follow-up question, and you're just getting angry at him because you're saying,
I'm not getting angry, but I get what your point is.
Even though you've been explaining it for 20 minutes, he has this additional question that now is just triggering you.
I get how I sound angry. I'm not angry, I promise.
Well, I mean, no, you don't sound angry, but I'm just saying you're clearly agitated.
I'll just respond really quick to what you said because it's valid. Right now, like I'm trying to like focus on what what me and him are specifically talking about. He's telling me about some other guy that he had a conversation with. What he's talking about with me is I specifically told him about F.L.A. Keating. And then he asked himself the question out loud, I wonder if these clocks could be affected by interference. It's a valid question. And I said, okay, in order to answer that question, you would have to actually look. And now it seems like he's dancing around the
so
fact
I'm
that
the
he's
guy
already
that has
looked.
to ask that
and I'm like,
question,
how have
not
you
the
already
scientist
looked?
that
You
conducted
just
this
asked
experiment?
yourself facetiously out loud, or not facetiously, but
I asked you facetiously.
You just asked yourself out loud, I wonder if these clocks could be shielded.
I asked you that.
Okay, so you just asked me, I wonder if these clocks could be shielded. The answer, you'd have to actually look into the experiment. And you were just trying to say that you already had looked into it.
Yeah, that's what I've looked into. I wasn't worried about it.
You've looked into F.L.A.
What
year was it done?
Did they use a Faraday cage or not? Again, this is the information I looked up. Did they use a Faraday cage? What kind of protection did they use to isolate it from anything else?
I'm not going to berate you for not
That's all I looked
for not knowing how to research properly, but that is not how I would go about it.
I didn't find anything. Did you say that you found something with a Faraday cage?
Well, first of all, I would start off. There's like an academic research site, or there's like a way you can search for research papers on Google.
I have.
I've find the original research paper.
I saw the picture.
I would find
have a Faraday cage.
Dude, I'm trying to answer your question, dude.
But I saw the picture of
I'm trying to answer your question, bro. I'm just trying to answer. And everything I'm saying, you're saying like just chill.
All right,
I'm just trying to answer your question.
For a specific thing, though.
Okay, I'm just trying to answer your question. What I would do is I would go on Google. There's a way that you can search for research papers. I would find the original research paper, okay? Or you can find other articles that reference the original research paper. Normally, there's links at the bottom. You could probably go to Wikipedia and find the original research paper, okay? Once you get in the paper, you actually have to read the whole paper and not just the conclusion, okay? Somewhere within there, you're going to see it discussed the timekeeping that they use. That's an integral part to this experiment, is the keeping of precise time. Mm-hmm. So they are definitely going to go over in great detail the scheme that they set up in order to maintain proper timekeeping. So I would just start there, but this is like a long paper. It's like 100 pages or something. But it seems like you're interested enough to have come up with your own theory, your own experiment, and you have questions. If you really wanted the question answered, you would start with actually finding the original research paper and maybe not even reading the whole thing. That's not realistic, I don't think, at all. Maybe just like doing a PDF scan, looking for keywords and shit throughout it. Like cesium clock, interference, like using stuff like that to like at least spend some time with the document in front of you, like 20 minutes, 30 minutes.
You're assuming a lot, bro. You're assuming I haven't. That's crazy.
Well, it just doesn't seem like
it doesn't seem like it to you because I asked you a facetious question.
Okay, I'm going to go on mute and I'm going to spend 15 minutes. I'm going to answer your question about what kind of
fucking Faraday cage. That's all I'm going to.
I'm going to go find out right now what type of mitigation they use for interference during the F.L.A. Keating experiment.
This is your thing. You should know these things.
Well, I'm just gonna go. I'm just gonna go find out. I have no problem saying when I don't know something off the top of my head, and I can go look into it.
That's making you a little angry.
Well, but you didn't. But you didn't do that. You could have just said, "I don't know." We'd have to look at the experiment. Like,
Yeah, let's find out.
I never claimed to know. I said that he could find it out.
No, there's nothing wrong with you claiming to know. I'm just saying, instead of saying, you know what, I'm not sure about that part, you took a conversation that was going very well and you just became very nasty. That's all I'm.
Okay, well, I understand why you think it sounded nasty, but I think what I'm just trying to do is like hold Jason to task. That like sounds like you're interested in
that I've already
but it
done.
actually requires work.
But it was a scientific experiment that
it actually
presented.
requires work to flesh out ideas. That's all I'm trying to say.
I'm doing that. You're doing that now. You're about to go and find out if
right. I'm doing the
you're
work
about
for
to go do
you. You're
work.
not getting
No,
into
I've already done the work. I'm telling you, you're about to go do the work for the first time.
It was the presentation that you brought.
Again, you're assuming I haven't done the work. That you're wrong because you're assuming.
Clock is, Jason. Do you realize how you sound right now, dude?
Bro, who gives a flying fuck about a clock? The experiment is a clock, and was it accurate when it got back? It wasn't. And you're saying it's because of space-time bending.
Yeah,
I'm just wondering if
brought up a really good question about the experiment, and I think you just got upset and
gaslight me right now. You are literally trying to gaslight me right now into thinking that you understand Fela Keating when you clearly don't. An integral part to
it's not that complicated, dude.
Clock. You do not even know what a cesium
who gives a
clock
fuck about that? It's an accurate clock, dude. That's all it is.
You thought it was a mechanical clock.
I asked you if it was, so that you could specify for the audience.
Stop trying to gaslight me into thinking that you know about Fela Keating. You don't know about it, dude.
Jason, it wasn't you. You literally didn't do anything wrong. I don't know.
Just trying to be scientific.
No, dude, you're gaslighting me. You obviously don't know what Fela Keating is, but you're trying to pretend like you've already done research on it.
No, he just presented a follow-up question to an explanation that you brought up, which was very clear up until a specific point where he had a follow-up question. And then when you weren't able to answer it, you just got nasty. And I'm actually disappointed because it was going very well.
Okay, so I'll answer your question. I'll answer the question for you. That's valid. I'll answer the question.
Was there a Faraday cage? Yes or no?
Right. You already know, though. It's like that's what you're trying to gaslight me into thinking.
Yes, sir.
And okay, so
am I going to set you on fire, or am I gaslighting you?
So have you modified it? Because the original question was, I wonder what they did to keep interference.
That was a facetious question. It's a lead-up question.
Okay, so what's the real question now? Did they use the Faraday cage?
Yes, that's the.
Okay. And what would a Faraday cage have mitigated?
Electromagnetic fields that it's going through.
Okay, what specific bandwidths and shit?
Whatever they went through. They went on an airplane and multiple.
Okay, hold on. Give me about 10 minutes.
2 airplanes. I don't know, 2 different directions. There's a lot of fucking variables. Two minutes. Start the clock.
Sheesh. That got awkward so randomly. I was not expecting that.
Are y'all talking about the Cavendish experiment right now?
Not sure the name of the experiment, but where they put the clocks on the flights and then.
I think it's called like an atomic watch experiment or some bullshit like that. They take 2 airplanes with 2 atomic watches and fly it around, and they say, "Oh, look, we went in 2 different directions. Therefore, space-time has warped and is manipulated. This one's time and space a little bit." And I asked Sydney if taking those 2 clocks up in the air on an airplane, all these air pressures and changing air pressures and electromagnetic fields and things like that, did they account for anything like use a vacuum chamber or a Faraday cage? And the unscientific part came out, or I don't know what the fuck that was. Definitely a reason why you might have fucking weird reactions to people in rooms tell you that. What you got, Brandon? Brandon's there. OG, what's up?
I feel like he got upset because I hope he doesn't come back. I'm not trying to trigger an argument. I just feel like he was explaining the parts that, were like he was explaining that when he had to explain something that maybe he couldn't answer, he just
wormed out a little bit, huh?
No, I was wondering, because the Cavendish experiment, right? Like, I understand it supposedly doesn't prove gravity or mass attracting mass. It's just like, I'm still trying to learn it myself, get the understanding down, the mechanism of how it's supposed to prove gravity existing as far as mass attracting.
It has two sets of spheres. Two larger sets of spheres, two smaller sets of spheres. Because if I said balls, I'd be pausing all day. You know what I'm saying? But there are two sets of spheres, okay? These two smaller spheres are on the one on you can do from the Amazon. It's like on a little toothpick, yeah? It's a little toothpick, yeah. And it has another set of another set of spheres that they form a gravity well because of the bending space-time. Okay, so it's bending space-time, forming these gravity wells, and then you see them start to undulate back and forth, like kind of like wobble, like back and forth like that, and that's them fighting each other's gravity wells.
So they're basically shifting in open space where anything could affect their motion.
Shit. Yeah. This Cavendish himself, he literally did the experiment 200 meters away, while standing in a fucking tree using a telescope looking through a window. So that his mass wouldn't affect the experiment.
Was it enclosed in something or was it outside?
It was enclosed in a horse barn.
Right. So that's what I'm thinking about, right? So when y'all explain it, and then you breaking it down even further, it's like anything could affect that contraption, right? Like I'm telling you, this is my theory that I developed on this. This is my hydrodynamic electrostatic flow theory. The Cavendish has to have a sphere or a cylindrical object. What happens there is just like a plane wing, when it goes through the air, or a helicopter blade, when it chops through the air hits it, and low pressure forms, and has to make a little fast layer that goes around to catch up to the air. That's just regular air, right? You with me? So when that happens, just like on a plane, dust builds up. And when dust builds up, and it makes what's called a contact layer. A contact layer, I'm going to draw it out too. Actually, I have it drawn out. The contact layer rubs against the laminar flow layer that's just constantly moving. And you see from volcanoes, thunderstorms, all this, we know how lightning works. It builds up a static charge. These rubbing molecules of dust. And this is what you're witnessing in the Cavendish experiment. You're not witnessing fucking two bending space-time. You're seeing two sets of spheres that are being charged electrically, right, by wind, basically. So that's what you're seeing. That's why I asked him, is the Cavendish experiment that you can buy from Amazon that you see on your professor's desk, is that grounded? And he didn't want to say yes or no. He knows and well it's not grounded, but he didn't want to say. Which I find kind of.
So is the Cavendish? I can answer that right now. Is the Cavendish experiment that you can get online grounded? I have no fucking idea because I don't even know what this experiment that you can get online is.
All right. What about the one on the professor's desk?
I'm just now getting into it. There's like 10 fucking reference papers that I'm skimming through right now.
Hey, so let me answer that question for you and say that yes, Cavendish apparatuses, at least modern day Cavendish apparatuses that you typically find on university level experiments, are perfectly grounded. It's those a specific model that I was looking at over torsion balance and just looking at the instruction manual, and it says it right there. This is the grounding apparatus. This is where you connect it in order to ground the apparatus. So hopefully that answers the question that yes, indeed, that grounding is taken into account to dispel whatever static charge that's built up. And I think the question that I was actually going to ask Jason is, where has it ever been shown that wind blowing over an object can cause it to build up any appreciable amount of charge?
Oh, that's a great question. Do you know what a TV antenna tower is?
Yes, I know what a TV antenna tower is.
Right. But those specifically ones in America, they're I say it like that because those are the exact names of it. They go up to 2,500 feet in the air, like super high in the air, right? And the shape of them are tubular pipes, right? Okay, stay with me now. Now, this hydrodynamic electrostatic flow theory is actually happening here because what's happening is it's actually building a charge. This Coulomb's law is invoked here too. What happens is it also builds up a dust layer on the tube because it has that flow, that fast layer that builds up that contact layer. Then you have the dust and the laminar flow constantly. And if you go to one of these antennas and you just touch it from the ground and you touch the pipe, it'll literally send hundreds of thousands of volts right through your body and fry you instantly. Did you know that?
How do we relate this to the Cavendish experiment specifically?
The Cavendish is doing this on a small scale.
Let me ask the question, because to what what you've just explained is you have an object that's at whatever high altitude in the air. There's appreciable amount of wind, like a velocity of wind that you have. And I think you mentioned it yourself that with the Cavendish experiments, when he did it back in the day, it was in an enclosed system, a barn. And then when they're done modern day experiments, there's examples of experiments done in vacuum chambers, experiments that are done in closed rooms where you don't have any appreciable amount of wind blowing or air movement.
Yeah,
so I think the question
doesn't require a bunch. That's
the question will be leading towards how do you quantify this amount of charge? Like if wind.
Well, we're not talking about hundreds of thousands of volts. We're talking about a small amount.
Jason, I know. Let me just finish the question so you can answer the question when it's done. The question I'm asking is, how do you quantify or explain this in an actual like grounded terms of wind at X amount of velocities blowing over an object of X diameter, and over time is going to build up X amount of charge, and this X amount of charge is what's causing this noticeable force between objects? Because it seems like you're kind of just saying that this is a thing that exists without actually showing how it exists.
Well, I mean, I just told you about an airplane. Did you hear that part? Airplane building up static electric charge?
I heard that part.
Helicopters. You understand that helicopter blades do this as well?
Yes, and I'm still wondering how you...
Explain to me why the helicopter blade is doing this, please.
Because the helicopter blade is moving at significant speed and moving through air at significant speed.
But what's happening now? What's happening at the most basic
level? I'm tying
level?
this down again back to the Cavendish experiment where you have it in a closed room where there is no appreciable amount of wind.
Yeah, apprecial wind.
I think one other last thing I wanted to point out is within this specific type of electric buildup they're referencing is called triboelectricity, where you have like static charge through friction or through contact. One thing that we know of is there's this thing called the triboelectric series. It'll tell you with certain materials how easily they will either gain or lose electrons based on contact. And I always like pointing this out that the Cavendish experiment is specifically done with lead for two reasons. Because on one hand, lead is non-magnetic, and on the other hand, lead is relatively neutral in the triboelectric series. Which is why I have to ask, you have this object that is neutral in the triboelectric series, meaning it doesn't easily gain or lose electrons.
That's fine.
You have it done in a closed chamber where there's no appreciable amount of wind. But your claim is that there is significant static buildup that is made that is now causing what we see as this force of attraction. You know what I'm saying? You actually quantify that and relate it, so it's not just words and Jason's theory.
Okay, so you can build up a contact layer on any surface, plane wing, glass ball, lead ball, anything can build up a layer of dust, which becomes the layer of dust that is being rubbed by the laminar flow layer of air that's passing by with the dust in it. It's going to cause a electric static buildup. It doesn't matter what the material the apparatus is made of.
And through Coulomb's law, which is something that you mentioned, we can if you have two charged objects, you can actually measure, expect, or what's the word I'm looking for? Predict the amount of force that's going to be experienced. So with that force that we see in the Cavendish experiment, and again, it's you that I'm asking this question to. I haven't done the number crunching. Maybe I could do it in my free time if I want to. But I'm asking you this since you're the one that's positing it as an alternative explanation. The amount of force that we see is something that's measured. So since the force is measured, the amount of charge can also be measured. Have you done any sort of actual quantifiable empirical look into this theory to suggest that the charge that is built up is actually sufficient amount to replicate the force that's seen? Because I think that's the required next step in order for anybody to accept what you're saying as a viable alternative.
Well, the next step would probably be grounding issues.
So what are these grounding issues? Because I've already mentioned that the apparatus is
right. When you look at where it's grounded, you'll notice it's grounded at the base, runs up through the top of the thing, and then it goes through the top of and down the wire. It never actually makes contact with the actual sphere.
It doesn't have to make contact with the actual sphere. It
actually does. It actually does.
It just has to make contact.
It actually has to be
spheres in contact with that. So this is two things that I will say from
path of least resistance, or that's part of the Coulomb's law. You're gonna have to understand that charge would stay right where it's at. It would not travel that distance.
I would posit that that's just not how charge works. So two things that I will say.
It's not how grounding works, sir. How long have you worked around electricity? How long have you worked around electricity?
These are the examples that I'm about to give.
Just curious.
How long have you
worked around electricity, though?
These are the examples that I'm about to give you. If you let me speak.
Okay, just curious.
So the two examples that I want to give are, in some work that I've done, we work with big industrial pumps who are outputting significant volumes of water at high pressures. Part of this is also part of what we have to do is also ground the pumps to make sure that there's no static buildup or static charge, so that anything that's flammable would not be ignited. If you look at the actual thing that we're grounding it again at the base of the pump using flimsy wires. And this is in industrial settings is enough to ground the entire pump just by setting a wire at the base of the pump.
Wire. What gauge wire are you using?
1 second. The second example that I wanted to give is also.
No. Before you move on, I want to know what gauge wire you're using.
I'm not sure what gauge wire I'm not an electrician.
You said flimsy wire.
Flimsy wire in the sense it's not like big industrial cable.
Is it what, finger wire? That thing?
I'm sorry?
Like a finger width?
Thumb width?
Broom handle size?
Literally just a piece of wire that connects from the surface of the pump to a grounding cable.
How about your battery, your car battery size? Is that like that size?
Sorry?
Oh, your car battery size.
Like the wires in the car battery?
Yeah, is that about that size, you think?
I mean, I can go up and just get a picture for you and then instead just show.
No, I'm just curious. Just wondering about these flimsy wires because you described them so flimsily, and I don't think they would allow you to install some flimsy, non-compliant wires that burn their whole place.
Flimsy in the sense of, Jason, the way I'm doing this for illustration is to show that the Cavendish apparatus we have it's a very small tabletop apparatus, almost like a toy. And we have wires that are able to ground the entire thing. And I'm saying that for big industrial pumps, we also use similar wires to ground the entire pump. So I'm just giving you an illustration to show that.
You just made a fallacy just now. You just said the apparatus on the desk is grounded. It's not, because earlier you said, oh yeah, the big giant scientific ones are grounded for sure. The ones on the desk are not.
Cavendish apparatuses aren't big, and they're literally if you look up a torsion balance, it is the size of a computer, like a laptop. You put it on the desk.
Cavendish's first experiment was pretty large.
Right, but I'm talking about modern day stuff. If you heard me say modern day,
it doesn't matter. Cavendish was accurate, so we're going to go with that.
But you asked me about if they ground apparatuses, and I'm saying that modern day Cavendish torsion balance.
But they ground it correctly. That's what I'm wondering.
They are grounded correctly, which is.
Did old Cavendish know exactly what he was doing when he was grounding that?
I actually don't know.
A lot of the theories that electricity wasn't even discovered at that time, so he couldn't have known.
Exactly. That's what I said. I don't know if Cavendish grounded it himself or not. But one funny part of this conversation is Cavendish did his thing some 200 years ago. We can talk about that, or we can talk about people who recreated it last year.
Okay, excellent. Because the last one, the most scientific one I could find, that won't take very long. I want to jamal you up here. The most scientific one I could find was a group of scientists in Germany. They got Cavendish together. They put it half of it in a vacuum chamber, so it can't be. They grounded that through the same thing. They didn't ground on the sphere again.
Why can't it be grounded if it's in a vacuum chamber?
Well, I mean, they grounded it the same way again. They didn't touch the ball and ground it straight to the ground. They They grounded the apparatus that the ball was attached to.
I'm still challenging this idea of yours that you think that.
Let me finish explaining the experiment, or else you'll never know what the fuck I'm talking about, right? Like, I'm explaining the latest and greatest in the Cavendish experiment. So they have another apparatus that they spin. It's a sphere that they spin. This one is not in the vacuum chamber. This one is literally sitting on the counter outside of the thing. They literally said, look, it's even outside on the counter, and it's still affecting the one in the vacuum chamber. They're making the electric static charge on the one that's spinning, because it's literally out in the open with everybody breathing on it, the air conditioner's going, and it's literally affecting the closest thing that could be manipulated with a magnetic charge to it. That's what's happening. That's all that's happening.
But I still want to ask you to elaborate on why you're making this claim that the grounding cables must be directed.
Okay, excellent. The reason I'm making the claim is because the apparatus on the desk work exactly as the one that are supposedly grounded correctly, and it's high science. How is the one on the desk working, and if it's not grounded?
But why do you keep on saying it's not grounded when I've literally told you that they are grounded? I've put a link in the chat.
The ones on the desk of the professors are not grounded. They literally come and they put them on the desk and they say, "Look, it's working."
Jason, we don't have to argue.
I don't have to argue because I've seen people do this. I know.
I'm telling you, I've put the link in the chat.
I've literally heard Neil deGrasse Tyson say, "Look at this professor." He puts it and he slams the apparatus on the desk. This is the thing. They don't ground them. But they don't ground them, and they still work. This is the problem you're having.
But Jason, that's actually one other thing that I was going to point out.
It's not true. It's not untrue what I'm saying. They don't ground them, and you still have the same results.
So that's another thing that I wanted to get to. If some people ground and some people don't ground, and they're still getting the same results. If you look within like the scientific method, your dependent and your independent variables. In one case, let's say the dependent variable is the presence of grounding or not. One person has grounded and they've done the experiment and they've gotten the results. Another person is not grounding, they've done an experiment and they're getting the same
apparatus.
Is that not telling you that the grounding itself is actually not a significant contributor to the final result?
Yeah, because the grounding doesn't matter in either one of them. It's the static electric buildup that is the issue. The grounding in both of them are negligent.
But the point of grounding is to dissipate static buildup.
But I'm saying in the one that you think is grounded, they didn't do it correctly, and it's not grounding it correctly. Are you not hearing me, dude? No, don't interrupt me. You're not hearing me. The one that you're saying is done correctly has not been done correctly, and there's still electric static buildup there. That's the problem. And then the one that doesn't get ground is doing the same maneuvers that the one over here that is grounded.
But Jason, that's like
the grounding is bad.
I understand that you're affirming that it's not grounded correctly. But I'm still going to have to challenge you on that because there is absolutely no reason. And I've put the apparatus in the chat so that you can look and we can both have the same visual.
Well, here's the thing: the scientists that are trying to upgrade this, they're trying to negate the static electric buildup. So I'm not the one that's making this shit up. They literally are trying to.
I understand. What I'm saying is you're claiming that grounding and connecting your grounding cable to the base of the apparatus is not sufficient to dissipate any charge built up on the cells. Yeah, to you. But I'm saying that to the rest of the world, that's not the case, and that's why I've given you.
To the rest of the world, that is not looking.
That's why I've given you.
They're not looking. They're actually not looking.
Jason,
that's the problem.
Jason, that's why I've given you.
No one's looking into this, though. No one's looking into this. They're all saying, like you're saying, "Oh, it's been grounded at the apparatus, so it's fine." When in reality, the path of least resistance applies here, and it would not. This electrical charge would not travel up this tiny wire. Who knows what the fuck the wire is made out of? It was piano wire, so that's very shitty conductor. Up and over, and then into the ground. No, dude, that is the most resistance you can possibly have. The charge would stay on the sphere, and that is backed by law. That is not backed by guessing.
Listen, I understand that this is what you're claiming is true. But I've given you the one example of big industrial pumps where we also ground just at the base of the pump. Another example that I wanted to give, if you're not interrupting me, is another example.
No, you're grounding at the base of the pump. The pump is made out of metal. The entire fucking thing has become a ground. What are you talking about, dude? That is not the same. That is absolutely not the same. But not the same at all. The apparatus is made out of plastic, and the Cavendish's was made out of wood.
But not the same. We're not talking about.
Jason, you know, there's a paper published in 2003 where a guy recreated that using an electrostatic model. He's claiming that Cavendish had no way to isolate the Cavendish experiment from the electrostatic forces of the Earth itself. Right, so in 2000, just a little while ago, he recreated this.
Please
published a paper.
But that's
So
it
actually got published.
Yeah, that's fucking tight. Dude. You got some leads on that?
Agreement's going to have to be met here one way or another. Because you guys keep affirming, I'm not talking about Cavendish's wooden apparatus 200 years ago. I'm not talking about somebody using a plastic apparatus.
No, we're talking about modern day Cavendish.
Right.
He just did this year, 2023.
I understand, OG. Again, I've put a link in the chat to a modern day gravity torsion balance, aka a Cavendish apparatus. The structure itself is made of metal, balls are made of lead, and the grounding is attached to the base of the metal. Jason has kind of affirmed it now, that when you're using pumps, that you're grounding it and connecting it to the base, well, it's metal, so the electricity can flow. It's the same principle when it comes to this gravity torsion balance. This small little tabletop apparatus, you attach a grounding cable, and Jason's claim is that the balls are still going to retain charge somehow. But the reality is that in other instances where we're grounding much bigger things, I've given you the example with the pump. Jason, hey, 1 second, let me get this last one out. One other example that I want to give is in the field that I work, when we're loading, and this is not just my field, it's just in general. And when you're loading and unloading like liquids from a truck into a vessel, you have to be cautious about static charge. So you also have to ground the apparatus. But then it doesn't matter where you attach the grounding cable. You attach it anywhere on the truck and connect it to the grounding cable, and you've grounded the entire system. Okay. So in the real world, within big industrial engineering projects, people understand that you can ground any single location of an object and you ground that entire thing, even if it's a truck or even if it's a pump. But Jason is claiming that the torsion balance apparatus, that it's not going to be sufficiently grounded. Like, based on what?
Because, let me tell you, based on my 12 years of experience installing in completely constructing wind turbines from ground to actual running wind turbine. I know for a fact that if you were to try to ground anything that you're talking about with a single strand of wire, which that apparatus is being held up by, it would instantly be fried, or the charge would stay exactly where it's at. And you would have all kinds of issues. That's why you need multiple strands. That's why you try to downplay the size of the wire, when reality, if you got a sufficient enough size motor that needs grounding, it's going to be grounded when you set it down. It's also going to be grounded when you wire it with a big 1/0 probably cable, if you're doing it correctly, which has multiple strands, because electricity wants to stay where it's at mostly, but it travels to the path of least resistance. So one strand wouldn't do it. That's why you need multiple strands. So the path, so it can get to its ground, is very easy.
Can I respond?
The bigger the ground, the better. Absolutely.
Let me respond really quick. Like, grounding is all about, like, what is the, like, potential for an overage, or like an overage or an underage in charge. So when you have like industrial equipment, motors, shit like that, connected to a power grid, first of all, like most factories and stuff are going to have several, like, I guess you could say circuit breakers before the actual motor. So there's not like crazy overages that they have to worry about. There is a manageable, like, maximum amount of a surge or an amount of power that they'd have to dissipate in any normal situation, bar getting like struck by lightning. Then you have bigger problems. But my point is, industrial equipment would need larger, I'm not going to say how much larger, but they would need larger ground wires. But when you're talking about grounding static charge from, like, it's this thing's not connected to, 200 amps of fucking 3-phase power, right? It's just like a desktop apparatus, and you're talking about dissipating overages or underages in static charge that are just like anomalous in the atmosphere. It's not great amounts of current at all.
You guys are taking advantage of that anomaly. You guys taking advantage of that anomaly, whether you know it or not.
No, Jason. To land real quick, my point is that on this desktop apparatus, you don't need, or even in a fucking like room lab, when you're talking about dealing with ambient like static anomalies, discharging that, you don't need a huge wire. It doesn't have to be some thick, crazy cable. It could be like the thinnest fucking wire. It could be like literally, like, it could be like thread thin copper spool of wire, and you'd be good.
Right. So I was actually going to say this too, Sydney, but I just want to agree with you first, but also add on to the point that when we talk about grounding, there's two types of grounding. The one you've mentioned is 100% true, where you're grounding, say, appliances to like handle surges in electricity, so over voltage or under voltage. The specific type of grounding that I'm focusing on is grounding to dissipate static electricity. And Sydney, you've kind of said it perfectly that grounding to like control over voltages, that like you're looking at big voltages. But we're talking about grounding to dissipate charge. That's why I mentioned with the thing of when you're loading and unloading fluids from a truck to a vessel, what you're concerned about is static buildup from the movement of that fluid, the friction of that fluid. You're grounding it, and it doesn't matter where on the truck you place that grounding cable, as long as any part of that truck is connected to the ground, the entire thing is going to be neutral. Same thing with the thing with the pumps that I mentioned. With the pumps, of course, you're grounding when you're connecting it to actual electrical input. But when you have friction moving, you're also building static charge of the fluid inside the pump. So in that case, you just need to, again, attach a cable to literally anywhere on the pump and attach it to the ground, and that is going to dissipate static charge. So in this case of the Cavendish experiments or the torsion balance apparatus, we're once again talking about dissipating static charge. Not high voltage, not high amps, just basic static charge. And Jason, you said it yourself that these are things that we have a system of equations to determine how much charge we're actually getting.
Whether you try to mitigate it down to zero or not, it still has to have a proper grounding, and it still will take the path of least resistance. Nothing you said is incorrect, but you're just trying to downplay it, and it's not going to happen. You can go down to nothing volts, but a little tiny bit, but you're still going to have to dissipate that, or else eventually you're going to build up enough volts to witness your little gyration that you believe is gravity.
And that's exactly why the apparatus, which you've linked at the top, includes grounding cables.
Grounding cables to the actual spheres themselves?
It doesn't
or
have
to
to
the
be
apparatus.
It doesn't have to be connected. I guess for two reasons.
I guess for you it doesn't have to be, but for me, I require a little deeper level of scientific experimentation.
There's another reason why it literally cannot be attached to the spheres, because the movement of the spheres is what you're trying to measure. If you're attaching cables to the spheres, you're hindering that move. Like
so that's the excuse.
You have to attach it to something that's not the sphere.
Yeah, you have to attach sufficient enough cablings to dissipate that charge, because one little tiny wire is not going to do it.
You just answered your own question, T. You can't isolate those spheres from the electrostatic charge, bro. You answered your own question.
I'm tapping out. You take over, OG. Take it.
T just answered it, bro. I don't gotta take over. He just answered it. He can't isolate those lead spheres from any electrostatic charges built up by the Earth. It's impossible to do so, bro. So, you answered your own problem.
I don't know how you interpreted that from what I said, but that's absolutely not what I said. The way that we're isolating, quote unquote, isolating static charge is by grounding the apparatus. Connect the grounding wire to the base of the apparatus to any other grounding cable, and you have grounded the entire system. Everything that is in contact with that system.
I don't know what you're not getting about more wires.
Even if Jason himself thinks that it is not true.
But more wires equal more flow. I don't understand why would you argue that?
Argue what?
More wire equals more flow.
Well, how much flow do you need? How much flow do you need for static charge?
More than a single wire.
Why?
Why? It's Coulomb's law. It just requires more to move.
You can't just invoke Coulomb's law.
That's why there's people that install car stereos. They have to know. Bro, if you're just going to keep spazzing out and interrupting me, you're not going to understand what I'm trying to say. Yeah, it's to add on, but you're literally not. You're just trying to interrupt me to say that I'm wrong before I'm even saying.
I wasn't saying you're wrong. I just wanted more clarification.
Go ahead.
I just wanted more clarification. You're saying that you need to have more wires. That is a very big
Yes, you have to have more strands of wire inside of the protective case.
Right. How do you support that? Is it because you know the amount of charge?
He was about to explain.
Yes.
And I'm
yes,
the type of
there is an actual law that allows you to calculate how many strands of wire you need to get a particular amount of voltage to a place. It's called Ohm's law.
Ohm's law doesn't tell you how many wires you need, but
oh my fucking god, dude! Yes, it literally does. It literally does. It literally tells you how big of a wire you need to get the certain power a certain distance. That's exactly what it is.
That is literally not what Ohm's law is.
It's literally what it is,
I will
bro.
give you the
what the fuck?
Yeah, that's
all right.
That's not
I'll give you the opportunity to
about resistance, right?
Right,
The longer
that's
the wire,
crazy. That's
right,
crazy.
more
So this is why you're losing this
Yeah,
battle.
no,
V is equals to IR. Voltage is equals to current times resistance.
It's about resistance.
Well, let me put it to you this way. If we had a plug-in and we stripped the wire at the end and we tied them together and then we cut one wire and you put your fingers on one end and your fingers on the other end and then we plugged in the plug-in, okay, would you rather have a bunch of wires in your hand or one single wire in your hand?
Wait, sorry, before we get there, I still wanted to get back to the point that you were making of why we need
More wires?
Need more wires. And you said because of Ohm's law tells you how many wires you need.
Yes, for the flow of electrons.
Since you're making this very positive claim, have you applied Ohm's law to the Cavendish apparatus to tell us how many wires? How do you know that one wire isn't enough? Is it just
because the static electric buildup is still present?
Right, no, but again, the question that I asked is it just a hunch that you need more than one wire? Or is it due to whatever analysis that you have done with Ohm's law?
Well, to properly ground it, you definitely need more than one single strand of wire.
I'm asking you why, and you're not asking why.
Ohm's law dictates that you argue with Ohm's law about this because one strand of wire is not going to be able to carry the charge. The charge is going to stay exactly where it's at, building and building. Maybe eventually, if it built up to a huge charge, it would. But it's not at that point. It's only to a point where it starts causing a little force, and then it starts gyrating, and then you shut it down because that's gravity.
Yo, even the work centers we used to I used to work on, right? When we were the open technology and we got all of the chips and the shit exposed, even the grounding cable that we used was more than one single tiny little strand.
Come on, facts, dude.
Right?
The question that I'm asking is, we're looking at literally a tabletop apparatus that is smaller than my PlayStation 5 in front of me. Jason is making a very positive claim that you need more than one wire.
I'm making the claim that that's not even grounded. You're not even listening, dude. I'm saying that's not even grounded. We're talking about some super sophisticated scientific.
Jason, let me finish.
So how tall?
I'm just saying before you go any further, I'm not talking about that one. So I am.
You can say that
what you guys are talking about, how tall? I'm just asking a question for the audience, man. We're listening to y'all go back and forth, want to know some shit, right? So check it. So with what you guys are talking about, how tall is this Cavendish experiment?
Yeah, we need to figure out which one he's talking about because I'm not talking about
because he just said a tabletop, right? Cavendish. I don't think that's what any of us were imagining.
I'm talking about Cavendish himself. I'm talking about that big giant horse barn shit.
And that would be a bigger gauge of a wire to be grounded properly.
That is high specifically up. Why I included this apparatus. And again, I'm going to make this point. If you guys want to talk about a 200-year-old experiment in a wooden barn, you can do that. But I'm talking about modern day recreations of this experiment.
Yeah, so are we, bro.
I've put a link in the chat for the apparatus. No matter how hard Jason wants to claim that it's not grounded, literally it's listed on there. This is the grounding cable. This is where we ground. So we can look on here and try to ground.
Again, I'm not.
Right. And then to the last thing that I was asking before Nomad asked this question is, again, Jason has made a very definitive claim. It needs to be X, Y, Z. And I'm asking, how much charge is in the apparatus? How much charge can flow through the wire? How are you now concluding that one wire is not enough? Because Jason's hunch, unfortunately, isn't going to do it.
So that's why I invoke law. But here's the problem. It's not. Why you keep calling it a hunch and shit? That's crazy. I want to know before I open this PDF. Did you actually go to the link that you supplied?
Of course I did.
Did it open a website?
No, it's not a website. It opens up a PDF for the manual of it.
And you actually looked at it?
I have it open now.
Okay, so we're gonna take a look at it together right now. This is your ultimate Cavendish torch.
Yeah, just like yesterday, Carlos posted a PDF about how military manuals, showing that they have to calculate for the curvature of the Earth. He didn't read it. I opened it up and read it, and it said 2 key words: theory and might. Right, when dealing with all of those calculations, in theory, you might need these calculations. It was not a requirement to shoot missiles in that
thing is,
publication.
you're not talking to Carlos right now. You're talking to
Yeah, no, I'm saying
Hey,
for
Dr.
example,
T. Brown,
this
did
is
you
why
actually-
should read what is
Yeah, exactly. What picture exactly is here that shows reality? Like I'm looking at this thing.
Didn't take.
I mean, everyone is literally a cartoon, dude. Like, I mean, this literally. I downloaded this. This is gravitational torsion balance 2 is what I have this saved under. I've already had this.
I don't know if you
literally have this already.
Equipment at all, but this is the.
Yeah, I've seen the equipment. I'm telling you. Do you realize
This
that
is
this
the manual
absolutely is
directly
cartoons
from the manufacturer's website? Of course, it's cartoons. It's a diagram of their apparatus.
Okay, excellent.
And it's a diagram of the apparatus that points out clearly where the grounding cables are.
What the heck? Hold on. Fucking hell. So we're going to go back here and look for this grounding wire. You said you've seen it right there. It is right there, grounding wire, and it goes to the top of this piece of. So this is kind of this is what I want real pictures, dude, because you got a bunch of cartoons here. What's plastic? What's metal?
When you make this claim, do you believe that the actual torsion balance will be different?
Yeah, I've seen this thing in real life. Have you actually?
I haven't seen a Cavendish apparatus in real life. All I've seen is pictures, videos, and this manual.
Yeah. So have you? I mean, you've seen the pictures of Cavendish's experiment. Could you go ahead?
I'm not talking
this
about
one.
a 200-year-old.
This one,
Jason, for the
this one right here. I'm talking about this one. You've seen pictures of this one. The video would be
this
better.
Particular torsion balance I have.
Let's go. Put that.
But I'm wondering. I mean, I could
put that so I can see what kind of materials these things are made of. Because I'm looking at this thing. And last time I checked, this thing was made out of nylon.
Jason, the point of a manufacturer's manual is so that you have all this information.
And again, you're asking electrons to travel a long, long distance when they're very, very comfortable right where they're at.
That's why you ground it. I don't know.
You're asking electrons to travel through a very tiny wire, a very long distance when they're very comfortable right where they're at. That's how electricity works, sir.
Again, Sydney had made
that's how a static electric charge buildup works. If you rub a balloon and you put a very long wire cable, hold on. If you rub a big balloon, beach ball size ball balloon with a big old wool and make a static electric charge on that ball, and you take one tiny, tiny strand of wire and you run it 100 feet and you ground it, do you believe that that's going to be enough to get that electrical charge off that sphere?
I mean, we're not talking about 100-foot long.
I'm asking you if you believe that, because I know you don't know if we can or not. Exactly, it will not.
But we're not talking about 100-foot
the question is, though.
It is kind of, though.
We're not talking about 100-foot long wires, do you think?
We're trying to understand we're trying to get you to understand how electricity works. That's what we're doing right now.
We understand resistance increases the further the distance of the wire.
All right, and the smaller the wire diameter.
You're trying to say that, right? Nobody's talking about 100-foot long wires here.
But I was using that as the extreme example to further exacerbate what I was talking about during the whole example. If one little tiny strand ain't going to be enough to cut it, it's going to stay where it's at.
But Jason, you still have to tell us why you're making that claim.
Ohm's law, dude. Like, holy shit, dude.
I understand Ohm's law. So you're going to have to then make this relation.
We keep going back and forth. It's really not going anywhere. You know what I'm saying? You have to at this point understand Ohm's law,
Jason,
and how it applies to what I'm saying right here. I don't think you do. It's because it's very fucking difficult to understand that thing.
The current times resistance. I know Ohm's law.
Yeah, but how come you don't understand that one tiny strand isn't going to be enough for an electric charge to leave where it's happy at?
Because my experience tells me that a single wire is.
What is your experience bolting a fucking ground cable to a fucking? Bro, please. My experience dumps on your experience.
Big industrial pumps.
Certified in this field, dude. What are you talking about, bro? What are you talking about?
Hey, you're not the only certified person here.
Yeah, but I'm literally certified in this field, dude. You know what a CPU looks like for a wind turbine? Inside of a hub.
I work with wind turbines. I don't know why.
It's pretty complex. And like what does OJ said, you have to ground yourself. You can't use anything. You can't even use a magnetic tipped screwdriver, because just the magnet field of that screwdriver will destroy the system. It literally had to buy special tools that were unmagnetizable.
We're not talking about big wind turbines. We're talking about a 20.
I'm talking about a very small tool doing that to a very sophisticated piece of equipment that's shielded for this.
And I understand that.
We're talking about. All right, so Dr. Brown, you said a 20-foot. So there we go. So we're talking about a 20-foot Cavendish, 20 feet off the ground.
But that was just me. Throwing out the number. I actually don't know the actual
centimeter Cavendish.
The torsion. If you look at the link, the thing that I've shown in the link, So the only one measurement that I see here is that little box on there. It says that box is 11 millimeters, and I'm just looking relative to the rest of the thing. It can't be any more than a 20.
Does it specify how to ground it properly? Like how to run a copper rod into the ground, or where does it say to ground it at? Does it specify? Because if you're doing this and you want to nullify that electrical charge, you definitely want to be very specific on how to ground this. What you want to do is take alligator clips and clip it onto something that's painted surface. Oh, and you see? Fucked it up already, see? So we're going to need something a little bit more official. I'm just saying, all I'm calling for is more science, guys. I'm saying we can find out things, but if you guys keep pushing this certain items out of the way to meet an agenda, we're never going to get it.
Also, another point that I want to make, again, you can look at the diagram for all these questions that you're asking. It's literally the official manufacturer's manual.
I'll be right back. I'm taking a 10-minute interlude to eat tacos.
You can't interrupt every single time. I made the point that obviously because of the nature of the experiment, you cannot actually attach the grounding cables to the balls themselves. The balls need to be free to move. If you look at this apparatus, the grounding cable is put as physically close to those balls as could possibly be. I was being very generous when I said the base, but you actually look at that apparatus, that little square. The 2 LED balls are inside that little square box, and then the bigger ones are outside that square box, and you can see the position of the grounding cable. It is as close to that as it can possibly be without actually touching the balls. And you're still going to have to tell me that these balls are building such an appreciable amount of charge that this single wire is insufficient to dispel that charge. And you're going to have to explain that quantitatively using numbers. Not Jason's thoughts, using numbers. You've invoked Ohm's law, which is an equation that uses numbers, so you must answer it using numbers.
Yeah, cool, bro. There's no way to isolate those lead spheres from the electrostatic charges of Earth by one grounding wire. But you can't do it, bro. They're hanging freely, so they're gonna build up an electrostatic charge. But I know you say the grounding wire connected to the entire apparatus somehow cancels all that out, but there's no way to calculate the entire mass of the Earth from this little tabletop Cavendish experiment, bro. So what I'm saying is the results of all of these Cavendish experiments all across the world are so wildly inconsistent that there's no way to conclude that this is certainly, a device contraption that's measuring the gravitational constant of the Earth and the mass, etc., bro. Because all these results fluctuate all over the world, right? And I can give you published papers from all sorts of scientific journals, the European Journal of Science, of Physics, where they say that we get so many different, results from these experiments. There's no way to isolate these lead spheres from the electrostatic force of the Earth. So it's really an inconclusive experiment altogether. But it was said that he was able to measure the mass and the gravitational constant with this ridiculous contraption. And we're just saying this has been repeated throughout history. And there's no way to isolate this from the electrostatic forces, from the Earth altogether. It's impossible. So, it's a completely flawed experiment.
If grounding does not isolate something from the quote-unquote electrostatic influence, then I don't know what else could. Grounding, the literal purpose of grounding an apparatus is specifically for this thing that you're saying can happen. The only reason why you ever ground anything is to isolate static charges, to dispel static charges. And of course, when multiple people are going to do an experiment, they're not always going to get the same number. But I've looked at several, and I'm talking here professional Cavendish experiments, not a high school teacher doing something with bowling balls in his backyard, not a physics student doing something with lead balls in his dorm room. Professionally done university level Cavendish apparatuses, they will all agree within a fraction of a percent of the actual gravitational constant. One thing that I will mention, though, is because the gravitational constant is such ingratiated within physics, that if 2 people are disagreeing by less than 0.1%, physicists will say that is a disagreement. But we're talking about 0.1% of a disagreement, meatball. So you're going to have to show me all these different things that you've mentioned of all these different people doing all these different experiments and coming up with vastly different numbers. Because as far as I'm concerned, from what I've seen, they all agree within 1% of the number. And that is good enough.
I'll drop the link for you, bro. I mean, it's the European Journal of Physics, claiming that it's not a consistent experiment to measure the gravitational constant. It's not meatball's words. This is the European Journal of Physics. So, that's all I'm saying.
Show us.
Got you. Hang on, get the link for you.
Yeah, I still want to understand why, to the rest of the world, grounding is a sufficiently sound process to dispel static charge. If it's big industrial trucks, if it's big fluid vessels, if it's big industrial pumps, grounding always reliably works. But suddenly, when we're in this arena of trying to tell people that the Cavendish experiment is the Cavendish experiment, all of a sudden, grounding doesn't work as the rest of the world knows it to work. It doesn't make sense.
Yeah, not when you're hanging lead spheres from a string, no. No, it doesn't.
Why not? Explain that.
Because it's not attached to the sphere. It's hanging from a string. It's not attached to the sphere, right? The lead sphere can build up a static charge, right? Yes or no? Grounding the apparatus and then hanging it from a string is not going to isolate those spheres from the electrostatic charges of the Earth, bro. Everyone in science agrees to this. Like, they all admit this when it comes to the Cavendish experiment, bro. So I mean, when you're grounding an entire apparatus, yes, but a sphere that's hanging from a string, that's not physically, it's not isolating those spheres, bro. That's the problem.
Meatball, can electrons flow through a string?
Oh man, bro, those spheres are going to build up an electrostatic. Unless you attach those spheres to the ground, unless those spheres are grounded, then no.
It was a yes or no question. Can electrons flow through a string?
I don't believe in electrons, bro. I don't believe in your atomistic worldview, bro. Oh, sorry.
Can electricity flow through a string?
Yes, it can flow through a string, yes.
So if electricity can flow through a string, how come grounding an object will not allow that electricity to also flow through that string and then be grounded and dissipated?
No, bro. You have to attach it to the sphere, bro. You have to ground the sphere. The sphere is not grounded. So
if it can flow through a string, why do you have to ground the sphere? No answer. Crazy.
Read the chat, bro. I'll put it in the chat for you.
What part of here explains why grounding an object would not allow the charge to flow through the string and successfully dissipate the charge? What part of those three paragraphs?
Because there will still be an electrostatic charge on those spheres, bro. Even if it's grounded. Even if it's grounded, bro, it'll redistribute itself, and there will still be a repelling and an attraction in that device, bro. So you can't isolate those spheres from the electrostatic forces of the Earth, bro. It's simple as that, bro. Final answer for me, right? So I'm just gonna get these links for you, bro.
How come when my operators are grounding their trucks, it's okay to sufficiently dissipate charge in the trucks? And when they're grounding their vessels, it successfully dissipates charge in the vessels. And when they're grounding their pumps, it successfully dissipates charges in the pumps. But suddenly, it does not dissipate charge in the 20-centimeter Cavendish apparatus. How come it works in every other case for big industrial equipment, but it doesn't work for a 20-centimeter apparatus?
You get a lead sphere, bro, and hang it from that pump or, that vehicle and, let me know. Get back to me, bro. You get a string and hang a lead sphere from it, and then you measure, see if it's totally isolated from the electrostatic forces from the Earth, bro. But all the physics agrees it cannot be done.
Hanson, you keep coming off me, but I don't think anyone can hear anything you're saying. Oh, another thing that I wanted to point out, we kept using the word string very flimsily, but the torsion ribbon, which is what the thing calls it, is made of copper. Copper being one of the most conductive metals. But according to OG and Jason, copper is not enough to actually dissipate charge in a lead ball, based on some evidence that they have yet to show, but...
based on the European Journal of Physics, bro. It's a flawed experiment. Right, there goes the link in the chat, bro.
Hanson, you was coming off mic, man. We couldn't hear you though, bro.
Yeah, and you're straw manning, by the way. They didn't say copper wasn't sufficient enough. That's not what they said at all.
He said the string is not. He said you cannot ground lead balls that are attached to a string.
Right. So you have to ground the ball, right? That's right. That's making a distinction. That's all my brother.
Nobody has articulated why electrons. I know this. Meatball, close your ears. You don't believe in electrons. Why electrons attached to the base, or to the not even the base, to a surface close to the balls will not allow electrons flow from those balls up into the copper wire, into the grounding cable, and out into the earth. Nobody has actually told me why this cannot happen.
Nah, bro, I'm just getting mainstream links for you, bro. You know, shit that you'll believe, right? That literally says that Cavendish is not a sufficient way to measure anything. The force of gravity, the mass of the earth, it's an inconsistent contraption that's built where the results vary, right? So you can say, oh, well, they vary within a minuscule point of the gravitational constant, but bro, it's even they admit, right? It's the European Journal of Physics, the first link going through the Cavendish, showing how it's inconsistent. Here's Forbes, a fact-checking link, and I'll get you another link that was published in 2023 that literally goes all over the same shit Jason was talking about, how you can't isolate this contraption from the electrostatic forces of the earth. No matter how much you ground it, you still can't do so, bro. It's still there. So I'm just getting the links for you, bro. I'm just getting the links for you, right? Because you arguing with me, and these aren't my words, bro. So I really don't like people argue with me. I'd rather them argue with the European Journal of Physics, bro. So you can argue with the European Journal of Physics.
The question I was going to ask is, did you read the first thing that you sent?
Who, Jason?
Because no, I'm asking you, Meatball, did you read this first link that you sent? Because the first thing that you said does not say anything about inconsistencies.
Yeah, no, I did. Yeah, hang on. I'll get it for you. I'll get right where I was.
Because this link is talking about, and it's actually one that I've seen before, it's talking about the misrepresentation of the Cavendish experiment. And one that I've also talked about before, of how Cavendish experiments, he did not set up his experiments and said, today I'm going to prove gravity exists, or today I'm going to find the gravitational constant. He actually himself did not measure the gravitational constant. And this thing that you sent is talking about the misrepresentation of Cavendish's experiment in scientific textbooks, of how it's often posited as Cavendish did this and he determined the gravitational constant, whereas that's not the case. So maybe the second link would be the one that talks about the inaccuracies in the result. And the second link that he posted repeats the exact same thing that I said earlier. There's not this mass inaccuracy with the gravitational constant. And again, it says it right there that there are the variations within 0.15%. So if one person is doing an experiment and they're coming up with G, and another one is doing another experiment and they're coming up with G, and those numbers disagree by 0.15%, I don't see how that is saying that there's inaccuracies in the experiment. 0.15% for all intents and purposes is exact. It's spot on. The point that I made, though, is because this is one of the biggest values used in physics, it would like to be known with increasing the accuracy. With the speed of light, two people can measure the speed of light and they'll come up.
Right, now read the last one, bro. And how do you isolate that 1.5% from the electrostatic forces of the earth? Right? The alternate explanation for what gravity has been all along, right? Besides this fictitious attraction force that you're claiming exists, right? How can you isolate that from the electrostatic forces of the earth? Are you going to run a grounding wire to everything, bro? No, that doesn't work. It's not going to isolate these gravitational forces from the electrostatic force of the earth, which admittedly are 10 times stronger than the forces of gravity, bro. So what I'm saying is the title of the paper says, embarrassingly, we admit we do not know the force of gravity, right? The constant, right? Gravity isn't a constant, it's an average. Gravity is it's an average. It's not a constant. So you're pretending up here, bro. You're pretending that it's 1.5. Right? You're pretending that it's within an error of 1.5, but it's not a constant, bro. It's an average, and you can't isolate it from the electrostatic forces. So what are we even talking about?
People, you have to read past headlines. The headlines
good enough science, bro. Good enough.
And you read the actual content.
You're ignoring the headline, bro.
And it says that I
you ignore the headline and you make your own determination of what the paper's saying because you believe in the force of gravity, which they also are admittingly is not net.
People, I read the paper. Not just now, by the way. I've read it prior. I read this paper because I talked about it on stage. That we don't know the force of gravity is because of this 0.15% discrepancy in people's answers. Meatball, 0.15, 0.1% of discrepancy. That is one thing. And the other thing with this second or the third link that he sent, I just looked up who this author is, Dr. Stephen Alonso. Is this the same person that wrote, and he is, I'm just asking just because I know I checked the other of his works on his website, Flat Earth as a Queer Identity, Challenging Normative Structures in Knowledge and Sexuality. Is this the one person that I should be listening to about Flat Earth and science and like gravity? And do you guys ascribe to Flat Earth as a queer identity? I mean, sure.
Yeah, I don't know what that has to do with this paper, bro. But I mean, you're spazzing out right now. It's spiraling a little bit. All right, I just focus on one thing at a time. I don't know if you did a background check on the person who wrote the paper.
I was just curious who he was, and I clicked on his name to see the rest of his works. And before I read a paper, I obviously want to.
Right. So we'll see that's typical, bro. That's what brain dead people do, bro. That's what brain dead people do, right? They try to, group everything that's like. Let's going back to COVID, bro. Like when Kerry Mullis, when he won a Nobel Peace Prize for the PCR test, and said it's not supposed to be used for a, diagnostic tool, and the entire world used it for a diagnostic tool, and everyone called him crazy, and they said, oh, he was an AIDS denier, right? So he's an idiot. He doesn't know what he's talking about. He's the man who made the test. That's exactly what you're doing right now, bro.
Are you telling me that
this person, all of a sudden, they may have degrees, they may be a physicist, but what they're saying is illegitimized because they said another thing, right? So when it comes to this specifically, they don't know what they're talking about because they said something else about something else. Bro, read the paper, bro. Focus here, bro. Focus. I know you can do it.
It's funny because all three of these papers that you sent are papers that I've read in the past. I'm not a stranger to this conversation. I've read all three of these things that you
said. You're saying to be a stranger to the conversation, bro.
Which is why I can speak to them in so much detail. I've referenced these papers in this conversation prior to you actually sharing them. There's nothing on here.
You've been acting like a stranger to this conversation. You've been hiding and ducking smoke for a minute, bro.
Hey, you're pushing this idea that you can isolate any of these Cavendish experiments from the electrostatic forces of the Earth by running a fucking minuscule grounding wire you can't attach it to the lead sphere because it needs to be free fall. It needs to hang freely from the device. But you're saying that this grounding wire is enough to isolate these lead spheres that are hanging from a string from the electrostatic force from the Earth. So you seem to be quite the stranger to this conversation.
I've given you my experience of working on industrial grounding project. Like this is. Again, no one on here is able to articulate why grounding an object or why grounding this position of the Cavendish apparatus, these torsion balances, will not allow charge to go up this copper wire into the grounding cable and out to the earth, thus dissipating charge. You keep on affirming that it is not working without telling me why it's not working. Why, in this case, can electricity suddenly not take the path of least resistance and then go and be grounded and be neutrally charged? Why, in this case, after grounding the apparatus, and I'm going to stress the 20-centimeter tabletop apparatus, can a grounding cable not successfully dissipate charge? Why?
I wonder why those big lead wrecking balls that are hanging from these construction vehicles, I wonder why they just aren't attracting mass all over the world, bro. Pretty much exactly what this Cavendish is. It's the same thing, right? It's mass attracting mass, right? If you think that that's what Cavendish is trying to relay, bro, mass attracting mass, like this is why you're a stranger to the conversation.
Stick on topic and answer that question that I just asked. Why is grounding the Cavendish apparatus at the location it is grounded not sufficient enough?
If they're not attached to the lead spheres, bro, I've already given my answer. The lead spheres aren't grounded, bro. They aren't grounded, and you can't ground them because the experiment is set up in such a way that it needs to be hanging freely from the.
People, have you jumped a car before? I don't know if you had to ground the car when you did it. You didn't connect, like you connected to literally any position on the car. So long as it is in contact, the entire system is going to be grounded. I've given you 2 other examples of where big industrial pumps and vessels, you ground any single location on that surface, and the entire thing is going to be grounded. So you have to tell me why the principles of grounding.
All right, where's the tabletop Cavendish that you're speaking about grounded? Show me.
So you've been talking this entire time without even looking at the link.
I mean, I know you can't ground the lead sphere, so it's really a ridiculous argument.
So long as anything those lead spheres are in contact with are grounded, the entire system is grounded. That is literally how grounding. No matter how much Meatball and Jason want it to not be true, that is how grounding works. If anything is in contact with an object that is being grounded, that object is grounded. Specifically when it comes to static charge, not like high voltage and low voltage grounding where you have like in industrial circuits. Static grounding. Look at the link up top. It's been there for however long I've been in this room. You've been talking without actually looking at the thing that we're discussing. Look at it. See that the grounding cable is put as close to those balls as is possible. And the entire system is grounded because that's just how electricity works. I'm sorry to break it to you, but that is how electricity works. Jamal, did you enjoy your chat with Black Muse?
Say it again, I ain't hear you, my bad.
So did you enjoy your chat with Black Muse in the previous room?
Oh, there wasn't much of a chat. I was kind of just jeering at him, telling him his stupid ass is going to have to pay me because he put his clown shoes in his mouth. and he's so desperate. Guy got no self-respect. He's still up there performing, trying to force a conversation with me. And I'm making my position very clear. You will never have another conversation with me until you pay me, or we'll talk in court. And he's just trying. He's talking about opening a room. He's about to open another room after his bitch ass. I'm like, yeah, bro, duh, I just said that. I'm like, you'll never hear from me. You'll never have another conversation. You're going to pay me. After I'm done laughing at your dumb ass, you pay me. You can continue your antics and maybe I'll humor you for the fucking content. But till then, there's nothing for me and you to talk about. He's just forcing it. No self-respect, bro. Other people are trying to talk to me. He's just forcing it, panicking, telling, yo, Coco, go in now. They're trying to bully it. Somebody go in on little monsters, and I'm just looking. Like, let me see how pussy I really are. And I'm looking, and nobody's moving the muscle. He's like, no, don't want me to go. You gotta go in. I'm just like, well, nigga, look at how you acting. No, I don't even want to talk to you. You're not a mod. You're up here freaking out, screaming on the stage. They be bullying them, and they be responding to it. That's the weirdest shit ever. How they let that corny dude bully them, bro. That shit is, oh, man. What a weird bunch, bro.
All right, I feel like I keep on going back to this conversation, but again, I was just reading the last paragraph on one of the last things Meatball said, and I always find it funny when people send papers to support a claim, but then they reach a conclusion that's not the conclusion of the paper. Maybe find one that actually has your conclusion. But this paper that you had, the point of like this 0.15% discrepancy in the values of the gravitational constant, which for all intents and purposes, you can consider it as actually like spot on, is talking about seismic vibrations within the Earth. Nothing about electrostatic or electric field influences. So I think you're going to have to find me that paper that is talking about how these variations is due to not successfully isolating charge. I don't think you will, because most people agree that grounding the apparatus successfully isolates charge. But no matter, so long as you're on the surface of the Earth, you're going to be susceptible to vibrations on the surface of the Earth. That is the one.
And electrostatic forces, right?
No, so long as the equipment is charged. No matter
right,
how
well,
much
you can't isolate it from the electrostatic force.
You can.
You absolutely can't do that, though, right? But you're saying that.
So that is
to measure this gravitational force of gravity, right? But you also need to assume the mass of the Earth, right? So without first knowing the mass of the Earth, you can't then calculate the gravitational constant G, right?
The mass of the Earth in the Cavendish experiment. You don't. So, and the question I was going to ask you is, maybe you can actually define to me, what does it mean to ground something? Why is grounding not a way to, quote unquote, isolate something from the electric field of the Earth?
You can't ground something that's hanging from a string, bro. It has to be attached to the lead sphere itself, bro. You can ground the apparatus, But those things are hanging from strings, bro. They're not grounded.
They're hanging from copper strings. So long as there is a point of contact that electricity can flow, it will be grounded. Again, no matter how much you want to rewrite how electricity works, we know how electricity works. If there's a path,
right, but you don't know how gravity works. You don't know how gravity works, Dr. T. That's the problem.
What's the particular apparatus y'all deliberating over?
Jason put the link in the
link up top, bro.
Talking about the Cavendish experiment, and I always have to stress this, not the 200 years ago wooden experiments in the barn, modern day recreation using highly sensitive equipment. Jason's point is that the experiment is inadmissible because it is not isolating charge. I'm telling him that it makes no sense because the apparatus literally has a cable there to ground.
Is there actually a photograph or video of this apparatus? Or
this is from the manufacturer's website. Like I mentioned this to Jason also. The point of manufacturers putting manuals is so that you can get all the information you need from that manual. I don't know what a picture is going to do that the manual itself is not doing. Or do you believe that the actual apparatus would differ from what the manufacturer?
I don't know. It's just weird, bro. The enormous strength of the Earth's attraction for the small masses in comparison with their attraction for the large masses is what originally made the measurement of the gravitational constant such a difficult task. For torsion balances invented by Charles Coulomb, provides means of negating the otherwise overwhelming effects of the Earth's attraction in this experiment, right? It provides a force delicate enough to counterbalance the tiny gravitational force that exists between the large and small masses. This force is provided by twisting a very thin beryllium copper ribbon, right? So somehow this copper ribbon is just completely negating these massive forces of this gigantic, enormous Earth. This is little tiny copper wire, bro, and it's grounding and just negating everything, bro. It's just like ridiculous, bro. This is a ridiculous experiment, bro. This is what I'm saying. These are the weird thought experiments that you guys have to create. You have to come up with these weird contraptions, bro, to try to say that you're actually measuring this gravitational constant, right? Which all of physics admits that is inconsistent, bro. So, I mean, you got it, bro.
Inconsistent to 0.15%.
All right, inconsistencies are inconsistencies, bro, right? It's not a constant, is it?
For the sake of education, I just want to explain to you that what you just read is talking specifically about how when you're on Earth...
I know what I read, bro. I know what you don't need to explain to me, bro. I know what I read.
When we're on Earth, we know that gravity acts downwards. The point of this torsion balance and the way that it is arranged is that you're looking at gravitational influences perpendicular to that downward force because the forces are moving left and right.
Right,
so that is what we mean by
right. Left to right, mass attracting mass.
Right, but then what I'm saying is that it is working independent from the downward acceleration, the downward force, by using perpendicular direction, left and right. That is what they mean.
That copper ribbon isolated it from the downward force?
Yes, because it's moving.
Okay, yeah, that's how you lost your mind, bro.
That's how perpendicular vectors work.
Right, you lost your mind, bro. Absolutely.
Unless you can explain
tiny ribbon. Massive Earth.
You can explain to me how a downward force of gravity is going to impact something moving left and right on the same plane. Since I'm the one who's lost my mind.
It's attached to a string, bro.
I know it's attached to a copper string. You read it. I read it myself.
What are you talking about? That's there goes your gravity.
How? Like.
Wait, I got the picture of the actual apparatus in front of me now. Where's this copper string? What's the thing that's suspended from the copper?
Let me open it up myself. On page, actually, you can look at the thing itself.
Yeah, I was looking up videos for the apparatus.
That long tube has the copper string inside, and that little box. If you notice, there's a little knob on the left side of that little box where the grounding cable is attached. Meatball's claim is that because the balls are suspended on copper strings, that is not enough to actually successfully ground the apparatus. My point is that so long as any part of those balls are in contact with any other part of the apparatus that is grounded, you're going to successfully dispel charge. And the one thing I also want to say is that we're taking this as if there even is an appreciable amount of charge built up to begin with. I've mentioned how lead is neutral, relatively neutral, on the triboelectric series. It is not something that is just going to pick up charge, just staying stationary in the air. So on one hand, you have to contend with the fact that there isn't even any appreciable amount of charge being built up. And on the second hand, contend with the fact that any minuscule amount of charge is going to be successfully dispelled using grounding cables. But apparently electricity doesn't work today. We don't understand how electricity works. It doesn't work right now.
mass attracting mass, left to right gravity, bro. You are funny, Doc.
Yeah, it's like I'm kind of like I'm looking at it right now. Looking at the pictures of it on the website, and I found a video. Actually, I'm about to watch some videos of it allegedly doing its stuff. But I mean, you're defending a debunked sort of a
Who debunked
explanation.
it? Who debunked it?
Michelson Morley.
Michelson Morley debunked the Cavendish experiment?
It debunked the mass attracting mass Newtonian model for gravity.
What did what did Michelson Morley have to do with mass attracting mass?
Not Michelson Morley. It has
I mean, you said Michelson.
Newtonian. It has to do with debunking the Newtonian explanations. Any Newtonian explanation that could presuppose.
We're not talking about like Newtonian explanations or not. We're just
this is a relativistic gravity.
We're just talking about the phenomena that masses have a force of attraction between them. No matter what someone might think of the mechanism of why that happens, we're not discussing that. We're just talking about the observation that once you isolate magnetism, once you isolate electrostatics, that you're still observing a force between massive objects. That has nothing to do with Michelson Morley, nothing to do with Newton or Einstein, nothing. Just an observation.
Yeah, I'm looking at some videos now. I just want to see how reliable the observation is, because people make all sorts of funky ass claims all the time about this globe, and they act like it's a fact because they have it printed on a piece of paper.
I mean, Meatball shared a paper that actually speaks very well to the reliability of the results. That's when professional physicists in lab settings under controlled environments recreate this experiment, that they're getting numbers that are within 0.15% of agreement. So Meatball himself has given us the evidence that these numbers agree. The paper does say that slight variation is due to seismic vibration that you literally cannot isolate.
No, that's cool. That they agree they don't understand the force of gravity.
My bad.
No, you good. I just want to say, since he mentioned the paper I dropped, they agree that they don't understand the gravitational force of gravity. Embarrassingly, right? Embarrassingly, they don't understand.
Oh, I see. You want to be a headline warrior. You don't want to actually look at the content of the paper. You just want to look at the headline.
Right, no, the paper, I know what you're doing. It explains in detail how embarrassingly they don't understand the force of gravity.
Are you refuting that, T. Brown? Or because that's
he's saying that they do. He's saying that they do. That this 1.5 error is that this constant is actually an average, not a.
I think it'll serve you right also to look at the paper before commenting on it. Meatball has shared a paper. The title of the paper is "Scientists Admit Embarrassingly We Don't Know How Strong the Force of Gravity Is." You read past the headline because we're not headline warriors here. We actually read papers. And you look and you see that the contention here is that with the other known constants of the universe, speed of light, or whatever, Coulomb's constant, these are known to insanely insanely high degrees of accuracy. By that I mean 0.0001% accuracy. But with the
pain in the ass for that gravitational constant, those electrostatic forces,
Hey, Meatball, you can't interrupt me from trying to speak. Right?
I'm saying just don't misrepresent what I'm saying, bro. Just don't misrepresent.
Finish my sentence for me.
Nah, you good. Go ahead, bro. You got it. Mike is yours.
Since you know what I'm gonna say, finish it.
I didn't want you to gloss over that, bro. I didn't want you to gloss over that very important part, man. Just you can't. Electrostatic forces, bro. Another pain in the ass for your gravitational constant, bro, which isn't a constant.
So yes. Anyways, Jamal. So the headline, of course, is a clickbait headline. It's interesting. Oh, so embarrassing. Why don't scientists know what the force of gravity is? And you read and you find out that the point of it is that scientists across the world would do these torsion balance experiments, and they come up with gravitational constants that vary to 0.15% of a degree. That is the embarrassing failure of science, is that scientist A is getting a number that is 0.15% different than scientist B. Then you read the rest of the paper, and then it perfectly explains that the reason why this current limitation exists is because these experiments are done on the surface of the Earth. You're using very precise and sensitive materials, and you cannot isolate intrinsic seismic vibrations in the Earth. Nothing about electrostatics, nothing about, we actually don't know what gravity is. It's talking about that 0.15% difference.
Just another problem in your gravitational constant, bro. It's not electrostatic force. It could be seismic. It could be the unbalanced table that you're putting your fucking contraption on, bro. It's a lot of things, right? It could be a bolt that's off, just by about a millimeter, right? There's a lot of things that come into the variable, bro. But that's why your constant isn't a constant. Right? You're just saying it as if it is, bro. And these results prove the gravitational constant of Cavendish, bro. When categorically they don't, bro.
It's a lot of things, but electrostatics is not one of those things. Sorry to say.
Okay, so when I get you the MIT professor, right, Walter Lewin, who says you can't isolate the gravitational forces from the electrostatic forces here on Earth, and the only time you would ever mention gravity is when you're in outer space talking about how planets are suspended in the vacuum of space, which also can't exist because it's a violation of entropy, the second law of thermodynamics. He says everything here on Earth is electric, right? We can use the electrostatic forces to pretty much counteract these gravitational forces because they're 10 times stronger than them, right? So it's pretty much we can throw gravity out here on Earth, and the only time we need to talk about gravity is when we're talking about Pluto or Uranus or Neptune, and how they're floating in the vacuum of space, bro. So he's the head of the physics department at MIT, but I guess he doesn't know what he's talking about either.
You're kind of jumping a little.
But I do find it interesting, though, Dr. T. I'll let you go, bro. I'll let you go right here, bro.
Does Walter Lewin say anything about how grounding isn't sufficient to dissipate a static charge? Because
I'm just looking at this, right? I've kind of jumped in the middle of your conversation. I'm just looking at this damn apparatus. You put this apparatus where? They took this and put it in a vacuum Faraday cage?
I mean, neither of them. It can just be on
put it on a table. On a table.
Wherever. It's small enough that you could.
You gotta be
Jamal,
kidding me. I thought this was in a vacuum Faraday cage.
It is small enough that... Jamal, can I answer the question?
He's in defense mode now, bro.
You just complained about being interrupted. Let me just give you my visceral response to just looking at this, right? I think you're joking if this is not at least in a vacuum and a Faraday cage, at least attempting to at least pay some sort of homage to the electrostatic force, electromagnetic force, but to just completely just put this on the table in a room with open air and wind flow, you're joking.
But Jamal, that's why I wanted to answer your question. It is a small, less than 20 centimeter apparatus. It exists on its own. If you want to put it in a Faraday cage, you can, which has been done. If you want to put it in a vacuum chamber, you can, which also has.
Okay, so all I'm saying is that did he cut off? What does that mean?
What does what mean?
No, you went on.
I thought you cut. No, I thought you cut off. That's how.
Oh no, that's right. I did get a call. I was saying you can put it wherever you want to put it. If you want to put it on a tabletop with open wind, you can. If you want to put it in the desert or underwater, you can. But that says nothing about what we're actually talking about.
Well, I think it says everything, right? Because if it's a discussion about whether you're observing mass attracting mass due to, I don't know what your position on the actual dynamics is there, right? Not just the assumption that it's the mass attracting the mass innately. I don't know what the mechanism is that you're invoking it. What mechanism?
I'm not invoking any mechanism. The only thing that I'm invoking is if you eliminate magnetism by using non-magnetic objects. If you eliminate statics by grounding your apparatus.
This is what I'm saying. Maybe if you took this apparatus and put it in the best vacuum you can get and Faradayed it, and then did some, lots of experiments, and you got consistent results, then maybe you can begin starting a conversation. But if you haven't done that, and you're trying to pretend that grounding that wire is grounding it from the greater electrical field that the room occupies, and everything is in flux all around it, that's a joke.
Jamal, have you either yourself personally worked on projects or worked in situations where you had to ground an object? Are you familiar with the concept of grounding?
I've done some electrical inside apartments and even cars and shit.
So from the experience that you have and from what you know about grounding, maybe you can explain to me, nobody else has been successful in doing it. Explain to me why grounding this tiny 20 centimeter apparatus is not sufficient to dissipate every single static electric charge in it. Also with the caveat here that these are using lead balls, which are neutral in the triboelectric series, meaning they do not readily gain or lose charges.
It's not true. It's very electrostatic.
So Dr. Brown.
Jamal, we don't have to argue.
You're saying lead has no electrostatic.
I did not say that. I said lead is I didn't use
Dr. T, hold on, real quick from the top, right? When you and Jason initiated this discourse, right? I believe Jason was under the impression he was, speaking about a taller Cavendish until the link, was posted above, and you're talking about a smaller Cavendish, right? So what Jason was saying was, yeah, it does take a bigger gauge conductive wire to dissipate, to allow those resting electrons to flow down, to ground.
Right, I agree. He did say that, and I told him that. Why are we talking about a 200-year-old experiment when we can talk about modern day recreations today? Right. If he wants to continue to beat up a 200-year-old, be my guest. I will listen.
All right, cool.
But what's the point of that?
Well, look, when we just barely look into it on YouTube, these experiments, we do see vastly different results. Do you agree?
I agree. If you're looking at a high school teacher do something in his backyard.
No. I agree. Hold on. Okay, that's cool. You agree. So, yeah, but you wanted to put the caveat. Well, basically, if they weren't professional physicists. Well, look, in the link I posted. Hold on. In the link I posted, he's a high school teacher, right? But you can see in the comments, plenty of physicists in college did the same experiment with different results. One comment I put in the chat. He said that they realized they got results and they believed like, yo, this shit worked. Like it proved, gravity in the spin. Only to realize that there was a series of earthquakes that was going on, like during the days of their experiment.
And this is 100% supported by the thing that Meatball said. Again, if you want to continue to harp on to amateur people trying to do recreation,
these are professionals.
I understand.
No,
listen to
what I'm about professionals.
I know that. I know that. Listen to the end of my sentence, or unless you finish it for me.
Well, I'm not talking about amateurs.
Okay? I understand that. Neither am I, which is the point that I'm getting to. Okay. Meatball has shared with us a beautiful paper that said that when professionals are recreating the Cavendish experiment, that they are getting numbers that agree within 0.15%. Is this the big variation you're talking about? 0.1% error? Or are you talking about errors when you have amateurs doing it? Because that is the distinction.
Over 10%. There's experiments.
I did not say over 10%. I said
I know, but I'm saying that there are results that are well over 10% in error.
Where are these results? Are they done professionally? Are they done by amateurs? Do we want?
I mean, if someone says if someone states that they are a physicist and did a controlled experiment, is that good enough for you? Or do you have to see their face, look at their ID, go to the fucking LinkedIn? What do you need?
Whatever. I'm telling you that when professionals are doing this experiment, they're agreeing within the point.
They just claim to be physicists, or you have credentials. I mean, if we're talking.
I mean, it's a lot of people in the comments claiming to be physicists. If that's the case, if all lying and giving details and data of the results, but they're just amateurs, though.
Even the Action
which
Lab
comment?
tried to do it. He's one of the biggest science channels on YouTube. He tried to do it, and he had that man. He failed. He couldn't do it. He can't do it.
Yeah, it's a lot of failures. It's a lot of inconsistency in this discussion.
Completely a parlor trick of configuration. This is why I brought up that, looking at that apparatus, if you sit that on a fucking table in a room and are talking about isolating gravity as a phenomenon from the electromagnetic forces that are all around and ubiquitous all throughout that room and proportionate and as per, coulombs and what Walter Lewin is breaking down on his board are completely interchangeable and cancel out gravity, nullifying gravity equationally completely in every single way that you would ever try to apply gravity to anything in the atomic scale, all the way out to the thousands of miles off the Earth, talking about some cosmological fucking fairy tale. That's where your gravity works. When you try to make sense of your nonsense cosmology, it's the only scale it works on or is relevant at all.
Jamal, I hate repeating myself multiple times. I'm going to ask you again one more time. Why is grounding not sufficient?
Because there is an electromagnetic and electrostatic and electrical dynamic playing out between the atmosphere in that room, right? You've seen the Feynman 100 volts per meter and the ground that the building is grounded on and the table and everything else. There is a dynamic there that is ubiquitous. You have not isolated that.
Well, that's kind of why I asked you about if you're familiar with ground. The point of grounding is to dissipate accumulated charges. If you have grounded an object, for all intents and purposes,
but it's
that object
sitting
is
in a
electric.
room
Jamal, let me finish. If you ground an object, for all intents and purposes, that object is electrically neutral. Even if you have a 1,000-volt electric field in that room, an electrically neutral object is not going to interact with an electric field. You mentioned Coulomb's law. That is what Coulomb's law tells us. So again, how come grounding this apparatus is not sufficient to isolate it from the electric field? Is this a case where electrically neutral objects are interacting with the electric field? Because that literally breaks physics.
Nah, bro, I just don't see how being exposed to that flux is just going to stay and not be influenced by that dynamic.
Do electric objects are neutral objects attract? You know Coulomb's law.
There really isn't. This is the thing. All these quantized, all of these equations.
Let me finish the question though. You invoked Coulomb's law
before you started. But go ahead.
You were on mute, so that's why I started talking. Coulomb's law says the force is Q is equals to the Coulomb's constant, whatever it's called, times product of the two charges divided by the square of the distance that separates them. If one of those two charges is zero, the force is zero. The point of grounding an apparatus is to make the charge of that apparatus zero. Is this you saying that there are cases where a zero charge, neutrally charged object can still be influenced by electric field? Is that what you're saying?
I'm saying that there literally is no such thing as being truly neutral in that sense, right? We quantize things and then you can get as, if we say we have one, whatever the fucking unit is, and then there's -1, and then there's 0 in between, and then things are always in flux. There's elemental charges. There is no such thing as neutrality in a true sense, right? So what I'm pointing out is this dynamic is ubiquitous. It's everywhere. It's in everything. So I think that sitting in a room that hasn't created to isolate that bigger dynamic that's at play between everything that consists of Earth or earthen things or things sitting on the Earth and things that are not attached to the Earth in the atmosphere. That's the ubiquitous dynamic that's everywhere Jamal, on this Earth.
You literally can measure and you can have zero charge. Voltmeters are made to detect charge. If you put a voltmeter connected to one end of an object,
what is the degree of accuracy of that?
Jamal, it varies.
There are units, right?
You can have a very highly sensitive. You can have a very
Are you
highly
arguing with the idea that things are always in flux and that there are elemental charges? Are you arguing with that?
But there is a range of flux. There is a range of flux. You can, and also there's a
so
resolution.
We can assume zero. We can treat it as zero equationally, but it is not zero.
I mean not zero. We can look at the uncertainty, the error in the voltmeter. There's a resolution for the voltmeter, and then we can specify that. And so long as the error is within the tolerance level, that's good. Yes, exactly.
Right. So it works for your equations and for your utility, right? So you create a system in the math and the way of defining these things. And in that system, if you call it neutral as your parlance, that's the way you choose, that's your nomenclature for your system. That's fine. I'm not against it. It's, for all intents and purposes, it'll be helpful to think of it as neutral. But is it truly neutral in the sense when you're asking me truly about the mechanics and how and why it's actually working the way that we see it working? Let me just finish because T. Brown asked this question, right? If you're asking me truly about the dynamics or the mechanics at play and why it would work, we cannot relegate it to the math in just your law. This is the problem with you model thumping, equation thumping, put in a box matrix guys, right? If you really are talking about the physics involved, hold on. If you're really talking about the physics involved, I'm just pointing out, like he said, there's a range, there's stuff. So this is why I'm saying until and unless I can see an apparatus like this taken into a Faraday cage, in a vacuum, right? Isolating a whole bunch of other variables the best you can. Well, then I can see how, and you get consistent results. But then you got the start of a conversation. But in my opinion, this thing just sitting on a table that's exposed to this ubiquitous flux and dynamic that is occurring between anything grounded or anything up on the earth and anything off of the earth or grounded that's in air and atmosphere inside the electrical field of the earth, right? You're not grounding completely or just that's not how this thing works. It's not like X-Men. You get a force field and No, but there's influence.
The follow-up, and I think I still have to point this out, where the principle of grounding an object is to allow either electrons to flow into an object or flow out of an object until that object is neutral.
Well, this is where we have a disagreement. We don't even think there are electrons.
So that's the thing.
Let me say the next thing that I want to say.
Electrons.
Let me say the next thing that I want to say is, and I've kind of brought this point up where we're spending so much time talking about this hypothetical charge influence. If we agree that grounding is a good way to get charge as low as possible, maybe it's not exactly zero, as low as possible, say 0.001 coulombs, there's still some residual fluctuation. The point of the Cavendish experiment is that at the end of the day, you are still observing a noticeable force. We know what coulombs. 1 second. Hey, Jamal, let me just. I'm gonna do it again and ask you to finish my sentence, because, like, do you know what I'm gonna say?
I don't know. You've been cutting off a lot, though. You don't get to cry that much. My bad. Go ahead.
Geez. So the point that I'm gonna make is that within the Cavendish, like, there's a measurable force that we see happen. That force can be recorded. That force can be measured. The question that I'm going to ask is, even if we assume a negligible amount of charge that is still left in that object, by what we know of Coulomb's law and the force that results from known charges, would that ever be enough to recreate the force that we actually observe? Because if it is a 0.001 Coulomb charge that we assume is residual, the force that we would expect from that residual charge, is that anywhere near the force that we actually observe? That is the next step that this conversation has to go. I would say no.
This is what I think the next step would be, what do we even actually observe consistently? That's the first fucking question. You keep talking about what we observe authoritatively. Like, there's some consensus or, like, well understood, but no, this is the most inconsistent joke of a trick non-experiment that there is. You know what I mean? The way you guys conduct it, in my opinion. So you asked me a question earlier. I'm just pointing out to you that if you are trying to pigeonhole me to electrons flowing in and out of anything, that's totally not even my paradigm. There are no electrons. You're just reifying something that I think
we don't even have to harp on that. Just electricity flow.
No, I do have to harp on that. That was your whole point that you were just going down the whole time about how.
Meatball made the same point. I'm like, hey, you don't want to call it electrons, fine. Just call it electricity.
All that crying and now you're interrupting me.
Because I don't want you to go on a diatribe about
I didn't want you either. That's why I was interrupting you. But you cried.
Hey, stay off. It doesn't have to be electrons.
No, I'm going to rebut everything that just happens in a sequential way, in order. I'm going to treat it in order, right? A bunch of things were said that I want to address, so that's what I'm going to go ahead and take the opportunity to do, right? You were talking about these laws, about these numbers, zero, neutral, and I'm just pointing out that, to me, in my opinion, what not just we, but as OG showed you, Walter Lewin, the head of MIT physics for decades, is showing you is that for every single intent and purpose here on Earth, from the atomic scale, anything above the subatomic scale, meaning everything in our reality that we see and interact with, all the way out to the cosmological scale, thousands of miles off of the Earth into outer space, imaginary land, there really is no need to invoke gravity, right? It is superfluous and it is superseded by electromagnetism. Right? Shows you that equationally. So now I'm coming from an ether background, not reified particles, right? There are no electrons flowing in and out of anything, right? So when you ask me certain questions, they're set up loaded questions inside of your paradigm. And maybe now, if you allow me to explicate a little bit, now you'll understand how this could be working and accounting for what I think is inconsistent. But if there is a consistent thing, it would be consistent unless it's in a Faraday cage, in a vacuum, and some sort of shit like that, well grounded, and a really apparatus that's built specifically for isolating these things, which clearly this one isn't, because it would have came already set up in such a way. But like I said, until and unless that's the case, what you're thinking you're isolating, it's already there in my model. It's the ether, right? And it's also the electrical relationship between anything that's off of the Earth and the Earth itself. There is a ubiquitous electrical dynamic going on there that is proportionate to gravity as far as inverse square, right? So if you say, and it's ubiquitous and it's omnidirectional, right? Same way. So my whole contention is with this, that there's not even consistent results from this thing. So it's already something you dismiss. I heard this, what's his name, was arguing this with Mick Toon, and he's like, if the experiment is set up right, you get the right results. And he's like, yeah, but what about everyone who doesn't get the well, then they didn't set it up right.
But is that not something?
Doesn't that sound like an out? Does that sound?
Jamal, is that not something that is worth considering? Like, I've done.
Man, so who are these? Why are these people who get the favorite results, even if it's college students?
Jamal, I just wanted you to.
Bro. I'm answering your question, bro.
I didn't finish the question.
You kind of did, but go ahead, bro.
I was gonna say, like, I've done experiments where this is within chemistry, where there's supposed to be a desired, an expected result. I don't know if you guys have heard of the iodine clock, and I've done it. My iodine clock didn't do what the iodine clock was supposed to be. Am I going to say that there's inconsistencies there for X, Y, Z, or am I going to first consider, did I set this up properly? I'm not saying that is what
you're going to consider that, but again,
but I'm just saying just dismiss it. Like,
wide.
Obviously are not going to set up everything the right time, the right way every
That's
time.
what you interrupted me to do that nonsense, mindless.
Right, because
obviously, you can set things up wrong, and you should take safeguards and take precautions and review your work and try things multiple times. Obviously, no one's saying to just assume you're right the first time. I don't know why we always got to go through these weird.
What was the point of then, like, highlighting the Mattoon comment?
Because he is literally saying anytime that the right result wasn't achieved, it's because the experiment was set up incorrectly. And we're literally talking about thousands of experiments with a high degree of inconsistency, high degree of competent people doing it, and the competent, only the super competent who get super lucky and can figure it right, and then they get the right outcome. Everyone else fails.
I can also say that anytime someone does not recreate the iodine clock properly, they have set it up incorrectly. I can say that with 100% validity, 100%
with a parlor trick.
It's not a parlor trick. It's chemistry. I'm sorry?
That's just a thing of configuration that you may just be using to confirm a bias.
But I think no, because the iodine clock, we know what the iodine clock is supposed to be.
I don't know anything about an iodine clock. I'm talking about Cavendish.
Right, it was just an example that I gave to.
Well, I mean, to me, it's useless because I don't catch the reference. So
I'm just saying it's an example where I can 100% unequivocally say that if somebody does not get the right result, they have just not set up the experiment properly.
Okay, what about Cavendish now? Let's bring it back home to Cavendish. So do you think that anytime someone sets up Cavendish correctly, they will get a consistent observation, and that if anyone who doesn't get that consistent observation that you think is the measuring of the gravitational force, then they have done something wrong and they've configured their...
100%. If I'm doing work right, I don't know if you guys can hear, but there's a train passing by in front of my house causing mad vibrations. If I were to do the Cavendish experiment and I get a number G that is 10% off the accepted number, I'm still going to consider, well, there's this big-ass train that's driving beside me.
And what if you get the right number? Do you consider whether or not there were trains offsetting your number?
I mean, you consider it all the time. You consider it all the time.
No, you don't. This is bullshit, bro.
Wait, why wouldn't you consider it? Like, it's the one thing that was in Meatball's article.
Where is this data set, bro? Where are these experiments that confirm this?
1 second.
Where is that?
It's the thing that Meatball had said where there was this whole issue with scientists don't understand gravitational force. They explained that the reason why they're getting this 0.1% 0.1% difference in variation is because of seismic vibrations that you literally cannot isolate. In certain places, you might have more seismic activity if there's more cars in the area. Certain places, if you try to isolate as best as you can and go to as remote of a place as you can, you're doing your part to isolate these variables. But there will always be these variables present. If somebody's doing the Cavendish experiment downtown in their city where there's cars and people walking, then you're going to see a higher percent of error. If somebody's doing it in the desert where there's nothing around,
my question to you is, who is doing this right? Where is the best, reliable, most isolated, purest Cavendish experiment that you have found to date that we can put up for examination? Because I think this is a big joke. This apparatus you're showing me set up on a table is a joke.
I mean, the apparatus is the apparatus. Like, you can move it to where you want to go. You can still put it on a table in a remote area. You can still put it on a table.
Okay, so let me ask you a very simple question, because you're such a bullshitter, bro. Listen, where this apparatus, right?
Bullshitty here yet.
All right, so this apparatus, I think you're always bullshit, but that's all right. Let's get past it. This apparatus, I buy it. It comes in the mail. Boom, I set it on my table. I guess, I don't know. Let's pretend they sold 1 million of these. 1 million of these have gone out. People all over the world have set this up. Where can I find the experimental data that suggests that a consistent observation is observed when you use this?
Just to interrupt one thing. Where's this water? The MIT professor, whatever he said. Do you have a link?
Oh, sure, I'll grab it for you. Hold on.
But yeah, the examples of the experiments are in the same thing that Meatball has shared. It on there, it lists, I think there was a table that has a bunch of different papers where people have done their Cavendish experiments. It shows what the gravitational constant that they've come up with. It shows the percentage error. Like, you can scroll up the charts and find the one thing that the one article that Meatball sent. It has that information.
Where did they conduct it?
I don't know. I could look up.
Oh, well, that would be kind of important to know if we got to take passing trains and planes and foot traffic and shit into account, wouldn't it? And pretend that we're getting a consistent result.
I mean, so I still also have to harp on, like, what exactly counts as inconsistency. If people are agreeing within 10%, is that inconsistency? 10% is, I would say.
Well, you tell me. You shoot, brother. The gun is in your hand. You shoot. You tell me.
I mean, it really isn't up to me. It's up to you guys. You're the one who don't want to accept the data as it is. If I say 10% is acceptable, then 10% is acceptable. If I say 0.15% is acceptable, 0.15% is acceptable. The link of the guy, the amateur guy who did the experiments, he said that, I think it was a comment that said that most people in high school physics or university physics classes would get a number within 10% of the accepted value for the gravitational constant. Meatball's paper said
using the same apparatus,
using the same model,
the same exact development.
I mean, not the same. They might not all be the same model. I don't know how many.
Oh, well, that's important, bro.
Why is it important?
Because my contention is that this is a parlor trick thing of configuration in the first place. That it has to be perfectly divided, and then you got to be super biased about every variable ever to pretend that you observed something. And when you observe it right, then it was right. And every time you got it wrong and messed up, then it was wrong. You just did something wrong. It's nonsense.
I think there's multiple manufacturers for gravity torsion balances.
Cool. What I'm asking you for is some control, right? I don't think I'm asking for anything unreasonable. I just want some control. I want a data set that's well controlled around this thing that's supposed to be revealing the physics of all of the universe and everything to us, right? It looks like a little jokey thing on a tabletop, and people are just placing it on tabletops, completely not isolated from the greater dynamic of the electrical, field above, and in its relationship to the Earth, which we're arguing up here in defense of as possibly being another explanation. And also,
I have addressed you to the link in the chat. It has a very nice table there that has a list of multiple different Cavendish experiments, the value for their gravitational constants and their error bars. Like, it's there for you.
So here's what I really would like to know.
But again, no. Before you get there, the question that I still asked of what counts as consistent results. I want to say anybody that is doing a homemade apparatus and is getting a number within 10% of the accepted gravitational constants, given all these vibrations, I would say that is consistent. I would say if it's not on a professional, I would say that if it's then on a more professional, standardized, controlled level.
You are just cherry picking a range of tolerances.
Jamal, you asked me. I asked you, and you asked me about my answering.
Because it confirms my bias.
I asked you the question.
Out that that's garbage logic and not science.
But Jamal, right? Within science, you have to pick your own determination of what your confidence interval is. But Jamal, that's why I asked you the question. You didn't answer it.
You interrupted me. I'm trying to answer. Am I going to get to go without being interrupted this time?
Specifically on the
very hypocritical and rude every time.
Specifically on the point of
it's just because I don't whine like this about it.
Are you going to answer specifically on the point on what is regarded as acceptable results?
Oh my God! I mean,
are you going to answer what is regarded as consistent results?
Bro, you cry every time I
Hey, Jamal, I'm still asking the question.
You're being kind of boisterous up here, bro. You're being prohibitively disruptive. Nothing can be done up here if you're interrupting this much.
Are you going to answer the point of what is considered acceptable
down a little bit? I'll just talk freely.
Yeah, ask the question. I'm going to go on mute, and then you can.
All right, gangsta, do your thing.
I literally asked the question. I'm on mute. Now you can answer.
Oh, okay. So like I said, I'm talk freely. Like I said, I made it clear what my tolerance is, just logically, some controls. Control the apparatus. Let's have a data set where everyone is using the same machined apparatus with all of the same as precise specifications, materials as possible, right? Everything controlled in that sense. One, right? This is my train of thinking, right? Two, we are controlling for the electrical dynamic and the atmosphere and everything as best we can. Any sort of noise in there, we want to control it as best we can. So we put it in the most powerful, convenient, vacuum that we can use for this purposes, and then we'll also Faraday it, right? So we're at least trying to put some attempt on isolating variables that we can think of that could influence this, right? Obvious ones. So if you show me that sort of control and then show me a consistent result observed, I think we can start a conversation. I think if you haven't done that, and what you're doing is taking ragtag, shoddy little parlor trick, rinky-dink shit that everyone is configuring to their own specifications, and then trying it 1,000 times, and then showing, oh, look, I'm getting close, ignoring 999,000, anyone who does it, and then completely just cherry picking a range and tolerance that's based strictly upon confirming your bias or your hypothesis is nonsense. It's good evidence. I'm not saying it's not a good undertaking and do it, but to present that as if there's anything at all conclusive about that, or even suggestive, all you're doing is suggesting that there may be a trend of something happening. You have no fucking clue exactly. You haven't isolated it from the electromagnetic greater reality that OG was breaking down to you, and that he mentioned that Walter Lewin shows you that there's no need to ever invoke gravity in our terrestrial experience. That's for the cosmological scale. That's to explain your nonsense globe in a vacuum.
Hey, can you just 1 second? You still haven't put up the Waterloo?
Oh yeah, my bad, bro. I was kind of looking at this Cavendish shit. My bad. Look at it.
Right, but I just wanted to point out that you did not answer the question that I asked. But I'll re-ask it. But I also wanted to.
Yeah, I didn't hear it. My bad. I just wanted to talk without being interrupted. You know what I mean?
I think the benefit of I disagree with this demand that everybody should be using the same apparatus. I think a benefit of multiple people using different setups, because at the same time, all you're trying to observe is the force between different masses. If multiple people are using different setups and are coming to consistent results, then it isolates the fact that maybe it's because of the apparatus that they're getting the same results. So I can put the link in the chat, but again, like I've been referencing you to the thing that Meatball posted. There was a lab in China where they did this exact same thing that I'm suggesting. They did the Cavendish experiment using two different types of apparatuses. It's still the same torsion balance, but two different types of torsion balances, and they're getting consistent results that agree. Now, back to the actual question that I asked is, what is a number that is considered as consistent? If 50 people do the Cavendish experiment, what is the percentage tolerance?
I don't know. I'm not a statistician, so I don't have that type of threshold off the top of my head.
It is an individual idea.
Okay, I'm just pointing out to you. I know that there are like.
I know very well you're not a statistician.
There are like mathematical, fucking statistical thresholds and numbers.
There's not.
I don't have any of that at the top of my head. All I would like to know is, has it even been attempted?
But Jamal, it is
because you're asking me hypothetically, what would be do you have anything like that, bro?
I don't think you're like getting the direction of the question that I'm asking. Like, it is a personal thing. If I give you 5 experiments and they all agree within 1%, would you say that that is inconsistent? If they agree within 5%, would you say that that is inconsistent?
What are you giving me? Everything controlled like the way I asked for it? Like, I'm asking you everything the way I asked for it?
Let's say that I give you. I just want to know, what do you consider as consistent results as a percentage error?
I don't know. That would just be arbitrary for me to just throw out a number.
It truly is arbitrary. It is. That's why I'm asking you.
I've given my arbitrary throwing out such an arbitrary threshold. I don't know, bro.
Because I
think about that. Maybe I would go do some statistics research on what is a good number for that, but I don't do that kind of work. I don't have that off the top of my head. I just want to know. I don't understand the bluff. You're bluffing right now. Do you even have such a thing? Because he's just bluffing. Why are you asking me that if you don't even have that?
This exists outside of statistics. The reason why I'm asking
No. Specific to the Cavendish experiment, do you even have such data to start that conversation so that maybe I can go brush up on statistics and give you a threshold and give you a meaningful number?
I will share you the link that Meatball posted since you refused to go up to it. But the reason why I'm asking this question is because throughout this conversation, multiple people have thrown out this statement, and I'm paraphrasing here, that when people do the Cavendish experiment, they get inconsistent results. You have said that. Meatball has said that.
What I mean is they'll sit there, they'll do it over the course of fucking weeks, spend sleepless hours and nights. They'll do it thousands of times. Maybe 1 or 2 times, get something. There it is. Is it working? Is it working? And then y'all will harp on that and ignore and throw out the fact that this shit wasn't working for weeks. Sometimes nothing happens at all for weeks. Sometimes the opposite thing, all types of weird shit happens with this.
Anyways, I've posted the link in the chat. Open it, look at it, because it has the exact information that you're asking. I will also, because it's within that same link, I will go find that China example that I gave you of the scientists in China doing it using two different methods and finding numbers that agree within, what was the thing that they say 0.15% or 0.5%. Again, this Steve Mould is I think it was Nomad or Meatball that put it in the chat. Steve Mould is an amateur scientist, a YouTube scientist who did his own version of the Cavendish experiment, came up with a number that is 10% within what is the acceptable number for the gravitational.
Let me ask you a question. Let me ask you a very honest, straightforward question, T. Brown. Let me ask you a very straightforward question, T. Brown. Hold on. The very simple, straightforward question is, be honest. Is it not incredibly easy for me to fake results in a Cavendish experiment and omit my errors and my actual experience and just confirm something and just try to get in on some glory of, oh, look, I measured gravity? Is it not incredibly easy for me to do that?
No. Because if you're actually showing results, you're going to actually show the data that is leading to that conclusion.
Where's the data? Who's observing this guy on YouTube who's a teacher who did that? What data?
Are you talking about just random people on YouTube, or are you talking about like professionally done formal Cavendish apparatuses? I mean, anybody can figure it.
That's why I asked you to present your best. Is it this at the top of the room? Because there's no Faraday, there's no vacuum.
The thing at the top of the room.
You haven't started the conversation.
The thing at the top of the room is not an experiment. It is just a link to the Cavendish.
Okay, so I'm wondering, where am I finding?
I'm going now to post a link in the chat. I'm telling you now that you'll probably not find anybody that is doing this in a Faraday cage.
So then that's what I'm saying. I'm telling you now, if that's the case, then you're not really having a conversation.
Jamal, let me finish my sentence. You probably wouldn't find anyone doing it.
Hell no, I'm gonna give you a hard time. You ain't respect. I'll be telling you to chill.
I mean, you can give me a hard time.
And be rowdy.
But after I say what I want.
You shouldn't have said nothing. I was gonna go on mute, but you shouldn't have said nothing. I'm not going to mute.
You probably won't find anybody doing it in a Faraday cage.
Relax a little bit. And that's why I said if you don't, then the conversation didn't even start yet. Y'all are joking. I came in the middle of a conversation with you and OG discussing whether or not you can isolate gravity, what you calling just this innate mass attracting mass phenomena, from the greater the electromagnetic dynamic. And you said yes, using this. And when I look into it, if you haven't met those conditions, you're not even serious trying to start this
is a thing of you guys against the rest of the world. In the
sense, let me say it is consensus. It's not even against the rest of the world.
It's not even about.
That's the point.
Hey, I got a question for you, T. Brown.
You can ask the question after I finish my speech. Everybody, and myself included, because these are things that I do at work.
That's what
we know how grounding works.
That's why we know that we talk like a flat earther, and then we turned around because of consensus.
So we know how grounding works.
That's why you said
I have gone out into the field myself.
Yet, but I'm almost there.
Jamal, I finished my sentence,
and then the consensus turned you
so
back.
I have gone out into the world myself. I have worked on projects where we're working with pumps and we ground the pump. We know that in that case, grounding dissipates charge. We're loading vessels from a truck. We're loading fluids from a truck into a vessel. We ground it, and we know that grounding dissipates charge. People are doing the Cavendish experiments, and they're grounding it knowing that grounding dissipates charge. Dissipating charge means you're isolating electrostatic forces. Putting it in a Faraday cage is literally not going to do anything different than how we know that grounding already works. You will never see anybody doing an experiment in a Faraday cage.
Because it does. You want to know why there's a difference, right? You're isolating the greater environment around it, not just the item itself, but the environment around it, where that dynamic playing out across the surface of that entire apparatus, no matter if it's grounded itself, it's going to have influence.
Hey, Jamal, are you going to put up the link or not?
Hey, real quick, T. Brown,
Jamal?
let me ask you this.
Jamal. Are you going to
what's up
the water link?
So I guess this is my question. Well, here, let me. Hanson's here. Hey, Hanson, what gravity do you subscribe to?
Hold on just a second. I want to ask Jamal for the link. Are you going to put it up or not?
Which link are you asking for, Hanson?
The Waterloo link.
The who?
Jamal? Waterloo, the MIT professor.
The guy that said something about
Walter Lewin. That's what you're talking about?
Lewin, yeah, okay. Yeah, Waterloo. Jamal saying that He's going to put up. I mean, I've been waiting here for.
I'm grabbing it, Hanson. You gotta relax a little bit, brother.
Yeah. Hold on, hey Hanson. After this, let me talk to you around for a second. If Jamal don't get it by then, I'll grab it for you. I think I got a link for it too. So Hanson, which gravity do you subscribe to?
Well, what do you mean, which gravity? It's Newtonian gravity or Einsteinian gravity?
Yes, which one?
Same thing. Huh?
They're the same. Did you say they're the same thing?
They are close. Very close. I mean,
what's the difference between them?
Einstein gravity include Newtonian gravity, and
in Einstein gravity, mass is attracting mass?
Yes.
Huh. So in Einstein gravity, is the Earth falling straight down, or is it going around, or is the sun attracting it around it?
In Einstein gravity, the mass or the energy distorts the space time, and then
right. So
okay.
So wait a minute. Which part of? Hold on. So how can you have mass attracting mass and a distortion of space time? Which one is it?
It's in Einstein's gravity. It's distorting the space time, and then each object is following in a straight line, so to speak.
How can you have both? How can you have mass attracting mass and the distortion of space time?
I'm saying that it's distortion. It's you present it as distortion, not the attraction.
Right.
You can effectively say that they attract each other. So wait a minute.
No. So it's not effectively. It's what's the causality? Is it the distortion of space time, or is it the mass attracting the mass?
It's a distortion of the space time.
So it's not mass attracting mass.
It's the same thing. Can I just?
No, it's not. Hold on, wait. It's not the same thing.
Can I analogize it?
They're not the same thing.
Can I analogize it with this? When we talk about
hearing you talk forever,
man. Hold on, wait. I'm asking. So apparently, this is a fucking physicist. He's a PhD he's a PhD physicist, and I'm asking him a very simple question. What was it you need to fucking simplify?
Yeah, I mean,
this is simple.
Yeah.
So I'm asking you: are you saying that mass attracting mass is the same thing as bendy space-time?
It's equivalent.
No, I'm asking, are they the same thing?
Depending on how you describe it. I mean, if I describe it in the same way...
so it's not how... No. Are they the same thing, or are they different?
They're the same thing.
So bendy space-time and mass attracting mass are the same thing.
Yes.
And this is the position of physics.
Yes.
This is everybody. Now, do me a favor. Can you show me where they say this in the mainstream physics?
So, can I ask you a question, Hanson? Just a simple question. This is real quick before we go any further. It's just like a thing to set the room, like for debate moving forward. It's one of the first laws of logic. Probably the first law. I don't know. I'm not like formulaic with that shit. It's kind of like in the background know it, but it's the law of non-contradiction. Right? You can't have two things be true at the same time that directly contradict each other. Right? So that's important to just keep in mind moving forward, right? Because if you're trying to say that Einstein and Newton's explanations for gravity are the same, then I'm just pointing out to you that that's a law of non-contradiction and fallacy, right? They have incompatible.
So let me answer that question. Okay, so they are equivalent, meaning they're not contradicting each other. So that the non-contradictions requirement is satisfied. Okay, and then also the Newtonian gravity and Einsteinian gravity. The Einstein gravity includes the Newtonian gravity in the sense that in the realm that Newtonian applies, that it's a low mass, low energy, and the low speed, then these two mathematical descriptions are very close to each other. They only differ in the high gravity, high mass, high high mass, high speed realm. They differ considerably. Okay, and then so in go ahead.
Finish up first, though.
Yeah, I definitely. I mean, almost finished. So in that the high speed, high density, high energy realm, they differ significantly. So that's why we say that Einsteinian gravity includes the Newtonian gravity in the sense of approximation. Okay, go ahead.
The question I want to ask, since you're a theoretical physicist, this will probably be the right question for you. The way I like to think about like mass attracting mass, curvature of space-time, kind of analogizing it with how electric charge works, how we know that like charges attract, opposite charges repel, opposite charges attract, like charges repel, in the sense that charges don't directly interact with each other, but one charge influences the local electric field, and another charge is influenced by that electric field. Is that an analogy to say that the way masses work is that one mass influences the local, geometry of space-time, and another mass is then behaves based on what that space-time is? So they're not directly interacting, but they're using, on one hand, the electric field as a medium to interact, and on the other hand, space-time as a medium to interact.
Yeah, I mean, you can say that. I mean, the thing is, the important thing is that you can generate the mathematics that you can generate the mathematics that gives you the observed to predict the observation. So if I can do the field and all that, but I mean mathematically it is the same as I say that the two charges just attract each other, and then in the Maxwell's equation, they are practically the same thing, and there's no difference in describing, say, that put a field or a particle, but in the gravitational case, I mean Einsteinian gravitational case, you can also because the field equation is describing the field, and then the space-time, the metric is a metric, and then but how do you measure the metric? You put in the test particle in it, and then it will manifest the metric in the space-time, and so mathematically you can describe how the test particle behaves or moves in that field, and then so you can basically describe that. You can describe the particle movement within field equation, not field equation, the dynamic equation trajectory, and they are mathematically equivalent to say that I'm distorting the space-time, and it's just a convenience. I can describe the distortion of space-time, and then and from there I just derive the trajectory of particle. Or you can go the other way around, but usually it's much easier, much convenient to describe the space-time, and then write down the equation, and then you derive the particle, and then the other way around. If you do the particle trajectory, yes, you can back reverse and back out the field equation. They're equivalent. It's just a matter of convenience.
Yes, I'll agree with that. And I feel like with this too, it's when people try to make it seem that there's this difference between Einstein's conceptualization of gravity and Newton's conceptualization of gravity, Newton is just talking about the what. The what is that mass attracts mass. It can be measured, it can be quantified. Einstein is now taking a step further and says it's true, mass attracts mass, that's the what. Now let's discuss the why. Why does mass attract mass? It's not like one is like superseding the other. It's just
I mean, actually, they are both describing what. But the thing is, the Einstein's gravitational theory or relativity describing covering a much wider range.
All right. How
including
come
things like black holes and
Yeah, but
all that.
in things travels in straight lines, right? Things will, in Newton's sort of version of inertia, things will travel in a straight path, right? And
yeah,
Einstein,
so is Einstein. So is Einstein.
No, it's not.
Saying,
It's a geodesic.
that's exactly. Yes, geodesic. That's a straight line.
It's not a straight line.
A curved space-time.
Curved path.
Yes, because it's
straight line goes around
to that
a
topology.
sphere?
Yes.
A straight line goes
it's
around
relative.
a sphere.
Yes.
How does a straight line go around a sphere? You see what I'm saying?
You have to understand how you define a straight line.
Straight lines go around spheres, y'all.
Yes, exactly. If you're on a sphere, on a surface of the sphere.
Hold on now. Straight lines are free of bends and curves, okay? Just to let you know that. Straight lines are free of bends and curves.
Yes, you have to open. Yeah, you have to open up your
That's literally
mind.
the only way a straight line can be a curved line. It's either
Right.
one or the other.
So
you guys do this nonsense gaslighting
listen.
and make both the same.
Listen. So if you draw a straight line on like a piece of paper, right? A flat piece of paper, straight line. But then you roll up the piece of paper.
That line is no
and
longer
the straight line. Yeah, straight line is still relative to the piece of paper. You have to, if the particle, if the pen is stuck to the paper.
So we're reifying space-time, nonsense, imaginary, made-up hodgepodge of a word. You just make a word, make an incantation. You say space-time, and then you reify it and pretend it's like a piece of paper, and then you bend it. And now straight paths are curved paths around the geodesic. Oh.
Yes.
Nonsense. Imagination
relative
like no magic.
Yes, you have to
sci-fi.
Open up your mind.
Genre of sci-fi.
Relative to the geometry embedded in this piece of paper, but embedded in the three-dimensional space, relative to the three-dimensional space. That straight line on a piece of paper is a curve, but relative to the topology of that piece of paper, it is a straight line.
Okay, what's the piece of paper? What's the piece of paper? What's in the analogy? What's the piece of paper?
But I don't blame you. It's a difficult concept.
No, don't patronize. My question to you is, what's the piece of paper in the analogy?
What's the piece of paper? That's a piece of paper.
Okay. So in the Einstein versus Newton straight line, curved line, what's the piece of paper that's bending? That's making the straight line be the same thing as the
right. Yes, it's the space. The space itself. The space itself is curved because it's curved, just like you roll up a piece of paper, and then but if your particle is confined within that piece of paper, as in analogous to this three-dimensional space.
So space is curved.
Then
you understand
the straight line, in the higher dimensional space.
Hanson, you cannot listen, Hanson. Let me stop you right there, partner. Space.
Yeah.
You can't just make nonsense statements and act like we have to accept them. Right? That is a completely illogical concept that you can bend space. Space does not have a material component. There's nothing physical about it. You cannot bend space. Where there is a physical thing to be bent, there is no space. It's occupying the space because space is a privation. It's a metaphysical privation. It's a concept in our minds, right? It's a linguistic sort of a mental concept. There is a metaphysical reality to space. I agree. It's an important concept to exist. However, you cannot reify it and pretend it's physical and then give it physical attributes or the ability to influence physics by bending it. That's gobbledygook. That's not science. That's not physical science. That's not logic. That's nonsense.
I'm still waiting for the water
mysticism.
Lose link. Can you put it up?
What link?
So he want the Walter Lewin thing. He want the
It's been in the chat. It's been there.
Where?
Hey, so I say all that to say, hey, T Brown. So are you there, bro?
No, wait a second. I don't see anything in the water.
Did you look?
Yes, I did.
If it's from Jamal, it's about 15 minutes ago.
14 minutes.
Oh, man, did T. Brown just leave?
Probably.
Yo, because I don't think he understands. He's operating
Bring
on
John
outdated
up.
information.
John, I want to hear John talk about virtual particles to make this thing all make sense.
Yo.
Get a good laugh. Braxton Jackson, virtual particles. He got the 18 on pseudoscience. Dark matter, bending, working space-time.
What is going on with that PTR that John's got, though? What the fuck? Go ahead, John.
John tried to stay hit with the PTRs and shit.
Epstein Island, like Epstein Island.
Hey, OG, you there, bro?
Yo, I'm here.
Next time you hear, if T. Brown is here and I ain't here, I need you to remind him. So this is what he doesn't know. He doesn't know that science has gone away from his mass attracting mass. He's operating on old information. He doesn't understand that they're now hardcore on Einsteinian bendy space-time. So please remind him that he's got to get the updated information.
Well, they belong to some convoluted camp out there that does exist. It's an indefensible camp. It's really just a propaganda camp that tries to reconcile people and act as if they're the same thing.
Yeah, I heard Hanson trying that shit. I heard him trying it. That was funny.
Yeah, the ones that do that are a little bit.
Yo, that shit funny.
Yeah, I was just trying to had a talk with him for conversation's sake, bro. But you're absolutely right, bro.
Yeah, no, they've moved on. Probably because it's indefensible. They can't, because that shit is falsifiable. So they can't stand on that for too long because motherfuckers keep coming with experiments like, hey, yo, I tried it don't work. Where's mass attracting matter? You know what I'm saying? So they're like, all right, well, fuck it. We got a new one for you. Bendy space-time. Ooh. You know what I mean?
Only unfalsifiable phenomenon. Or
that's the only way this shit stays together. Yeah, that's the only way it stays together. They can't keep it together.
if it's falsifiable, we don't want it. It has to be unfalsifiable information.
Yeah. They can't do falsifiable shit. Oh, hey, so I had to go yesterday. How did my man Jay do? I heard him say he was in there in the lab researching, man.
He was listening.
Jay, where you at, bro? Hey, yo.
Did he watch the Back to Basics video yet?
I thought he was saying he did. Who the hell put John's face on the fucking poster? Hey, yo, that shit is hilarious.
John did.
Hey, were they throwing eggs at it?
Nah, it's not real.
It's probably one of them little AI joints where they have
that's not real. You can do that in Photoshop.
Hold on, man. Let me see.
He's not worthy to be praised.
I'd be willing to bet that's his daughter and wife or somebody like that. And they got a big ass picture of him. I think they actually did that for real. Hey, John, is that a real picture? I'm willing to bet that's a real picture.
John, come up and have a conversation, man.
Nah, I just want to know if it's real. Yeah, stay your ass down there, John.
Absolutely.
I was just saying because he was talking to Jamal.
Anybody can see that it's real.
It's observably real. It is a observable fact that it is real. Yeah, John. I just want to know, is that how observable is that? That's amazing.
John, you know the fastest way to Harlem?
Hey, took a look at the water Lewin's video. Where does it say that the gravity doesn't exist?
Are you talking to me? You talking about the Walter Lewin thing?
Yeah, the Walter Lewin thing. Jamal.
Did I say that he said that gravity doesn't exist? Did you hear?
No, I mean, what's the point of that video then?
What's up, Paige?
OG, you want to take them?
Yeah, what's the point of that video then?
All right, so here, let me ask this: what did you hear him say?
No, I mean, what's the point of you putting up the video? I thought.
No. So wait a minute. Did you hear him talk about gravity in the video?
Yeah.
What did he say?
He's describing how to compute gravity, and then in comparison to the electric force.
Right. So what did he say about gravity and the electro force? What did he say?
He's saying that the gravity in the low range, short range, is smaller than the electric force.
And so,
did he just?
What is that smaller?
Yeah.
Right.
In the low close range, yes.
What did he say?
What did he say? I mean, he said it's a smaller when in the particle. If you have a atomic force, if you have protons and electrons, and the gravitational force is very small compared to electric the force.
What else did he say about where gravity is
no, I mean,
utilized?
You're putting up this. You're putting up this.
No, I want to know if you actually understood what he was saying.
State your thesis.
No,
yeah. What's your thesis?
If you watch it, because the thing is, so I haven't watched the clip that he shows you, but I've seen what Jamal talks about.
So I mean, if you haven't seen it, well,
no, I know I've seen the video, and I'm sure Jamal played the one that's the part that's important when he talks about where electrostatics is fucking utilized and where gravity is important.
Yeah, that's just like a 3-minute clip that I put. It's a longer video.
Right. So where did he say
why don't you
start to deal with gravity?
Clip. Why did you put up the right clip?
No, Hans, I'm asking you.
Irrelevant.
Then
we will talk about it, right? Okay.
Where did he say that gravity is important? Well, at what point did he say start to deal with gravity? I have. I said I seen it 3 times.
Okay, so where
did he
talk about?
Where
if
did
you want
he
to talk about,
say?
I'm on the video, and then why don't you tell me which part that you want to talk about at the time
Did
stamp?
you see where he said that you start to deal with gravity? Where in the universe
the whole thing,
did he say
the whole video is talking about gravity?
Jesus Christ.
Yeah, I mean, what's your? I mean, can you point to me the time span where it's timestamped that where you find it? You want to use it as a quote.
Alright.
Bro, it's like a 3-minute video. You can treat the whole thing as just one quote.
Yes, I said. So I don't see anything like he said gravity is a hoax. Gravity doesn't exist. He said nothing of the sort.
I'm sure Jamal didn't say he said that.
So what's the point of that video then? I mean, you put up the video. You were quoting Jamal. You were quoting that video over and over again. That's why it piqued my interest and looked into it. And so what's your point in putting up the video?
Where did he say gravity is used functionally?
What do you mean? What are you talking about? I'm saying that I'm asking Jamal why he quoted this video. I mean,
I'm trying to figure out if you actually watched it, or you understood it. Did you understand what he was saying?
I understand what he's saying.
So on Earth, functionally, do you use gravity? Is gravity the force that people have to contend with?
Yes.
Is it influencing anything here?
Yes. I mean, what's your point, Jamal? I'm asking you, what is the?
That's
point
not what he said.
No, Linnell, can you just pipe down? I'm asking.
No,
Jamal,
so again, I'm asking you a very simple question.
Is putting up the video, and I'm asking him what is his claim regarding the video.
You asked me a question.
Yes. What is your claim regarding the video? What is your?
I walked in the middle of a conversation with Dr. T. Brown and OG, where it seems like OG was defending the position that
Cavendish experiment is not conclusively proving anything about what you suspect is this thing you call gravity or any way that you describe it, and it's not isolated in any way from, the greater part of the electromagnetic field of the Earth and the atmosphere and whatnot. And so I was kind of pointing this out to say that this kind of supports that idea that here in our realm, right, from the atomic scale and our scale of reality where we exist and make observations, gravity isn't really even to be invoked, right? It's superseded completely and canceled out equationally by electromagnetism, right? And this is what he's showing and saying in that video. The electrical forces are what govern this reality. What governs the cosmological scale is gravity, right? Because that's how you get your balls of gas that congeal and cool down and turn to, right? That's how you get that with your gravity mechanism that you just invoke up in the sky while we look at little dots move around, right? So that's what I'm using that to support the idea that it's like OG said, whatever you think you're observing with Cavendish, how are you isolating it from the electrical influence here,
But so Louis,
and he's saying by grounding it.
Yeah. So what's his name? The Waterloo Lewin isn't saying that gravity doesn't exist.
I never said he said that. Down. Why would we even bring that up? Why would you mention that? I never said.
Well, because the video. I mean, I'm trying to understand why you brought up the video.
But did you hear me suggest that somewhere in this video you were supposed to elucidate that gravity doesn't exist?
He didn't say that. That's exactly the point, right?
I know. This is what I'm saying. You even mentioning that is just muddying up this conversation for absolutely no reason. Just throwing that in there for no reason.
Because I was curious. So you're saying that the gravity is very small. Is that your point? I mean, using this video to say that?
No, not small. Did you look at what he showed on the board, on the chalkboard, as he's canceling them out on either side of the equal sign, and then he's pointing out it's literally not even a thing, right? It's kind of superfluous. You can do without it completely. You can literally listen to what I'm saying, Hanson. He's pointing out you can literally get the equivalent explanation without the G, just isolating and using electrical forces.
Yes, because if
you use that's my point. That's our point, and that's OG's point. That's what I think.
So you're saying
because it was really OG who mentioned it first, right? In the conversation, I walked in and heard, and we all familiar with the lecture, right? You can go. I'll try to find you the whole lecture in its full context, so you can watch it. But it's available there. You're also not an invalid. You don't have to sit and wait for me. Like, he has his channel with all his lectures up there. You can go find it.
Okay, so your point is, let me just restate your point. Your point is that because the gravitational force is much smaller than the electric force. That's
not right? much smaller. It has an exact equivalence inside of electrical equations, right?
What do you mean exact equivalence? You mean the mathematical formulation are similar? Is that what you're trying to say?
Well, according to him and what he's showing on the board, I'm not super handy with those equations, but according to him, and I suspect also Coulomb's law, you see there's an equivalence.
The equivalence is the mathematical formulation he's talking about.
Exactly, because that's what I'm saying. And the formulation simply is derived from the observations.
Yeah, so they are.
So there it is. So similar. How do you separate the observations from an electrical explanation? That's the point.
Yes, I mean, but that's they have the same mathematical formulation.
So how are you isolating
apart from the Yes, it's apart from the coefficients. So yes, you can.
So the question that OG was posing that brought this whole clip up was, how are you isolating it with a Cavendish experiment?
Right. That's a good question. So basically, I heard when I was here, I heard Doctor was saying that you put the shield, the electric shield, or the Faraday cage, and then also ground the apparatus so that the net charge would be neutralized or almost neutralized. So comparing to the gravitational force is negligible. That's how you that's how you distinguish the two forces. You heard what I said, right?
Yeah, I heard you, brother. I heard you. There's just a lot going on, you know. I don't know if I'm prepared to go to the long haul in this conversation with you a little bit preoccupied. But I remember how we went the last few times. I don't know if anybody else wanted. But yeah, man, there's you know, sitting this thing on the table in the classroom with the, you know, this influence of the dynamics going on in the room and the atmosphere and the greater electrical field of the Earth and its atmosphere, which the big ass, you know, which the building is sitting on. It's a lot going on there, man. That's ubiquitous and it's proportionate to gravity, right? And mathematically, right? So I just want to know how I would just like to see these things isolated to the best of their ability to prove that no, it is indeed some sort of mechanical, in the, like a Newtonian sense, or perhaps even in the Einsteinian sense, perhaps that, you know, indeed it is these balls bending and warping the space time, like creating gravity wells, right? The bigger ball is creating a gravity well and attracting the smaller ball toward its gravity well. Like, that's fucking phenomenal. I didn't even know it's pretty much this dynamic that is how they got the weight of the Earth. They hung a platform. They built a platform, perpendicular, you know, a nice level square platform hanging off 2/3 the way down the mountain, and hung like a plumb bob, and watched how the plumb bob was attracted to the mountain gravitationally.
Insane, bro.
And they were able to figure out the gravitational relationship between that mountain and the Earth, and therefore how they extrapolate out the weight of the Earth.
Yeah,
that's what I'm saying.
That's how we weigh the Earth. How we weigh the Earth. John will tell you. John, absolutely, it was observed. Anyone can hang a platform in a plumb bob 2/3 down a mountain and weigh the Earth.
Well, it's because it's very close range, and then it's 1/r squared. So you can plot the attraction. I mean the torsion when the two balls are at different distances.
Bro, that's what I'm saying. Though. The only thing that exists, bro, are these ridiculous thought experiments, right? If I hang a plumb bob from a mountain, then somehow I can, you know, extrapolate out the weight of the Earth, bro. This shit is so ridiculous on its face. Like, this is why it's been abandoned, bro. And they're talking about the curvature of space and time. Like, bro, shit doesn't get any more comical than this.
It's sad, man. It's sad we grow into our adult years and we still can't see the nonsense of it, and we are attached to these fairy tales. It's fairy tales. The nice fairy tales. I like them. Hey, does that make you feel better? I think a lot of us like them. Like, we're probably a little aggravated at how, you know, people have it's kind of like how I feel about a lot of religious stories. I like them. I kind of get annoyed at how people turn fundamentalists around them and put their brain in a fucking matrix around these ideas and lock them up forevermore. But that's kind of frustrating to see. But I like them. They're good. So it's a cool story. I like it. But it's just a story, bro. If it makes you feel good, hang on to it, bro. But if you're trying to tell everybody that that's how they have to define the universe and then some people in this savvy day and age are going to laugh at you. You know, quite spiritedly, we're going to laugh at you and pity you and, you know, keep it pushing, right? We're not going to humor your fantastical ideas about what we see in our reality when we know that it is all absolutely defined by pseudoscience, not actual science. Like pseudoscience. That's the main takeaway here, right? That all of those ideas are fine so long as you're honest about their pseudoscientific status, right? Those are pseudoscientific ideas, thought experiments. There's some nice elaborate math exercises you can do to entertain them and occupy your time. But, you know, you guys don't have the upper hand or the
It doesn't hit the way you think it does when you're talking to people who have simply looked at the earth and opened their fucking eyes and see, holy shit, that mountain's right there. It's not being refracted up. All of the water's flat between me and it, and it's all flat. The shit's all flat. Why do I keep gaslighting myself to make it curve and then uncurve? If you see enough of this lack of curve, your mind is gonna get tired of saying, curve, then uncurve. You sure of that? Even a mirror at 20? Everybody goes through it. Some people look and are honest because they're actually interested in the Lord Chilla said it very eloquent the other day. He said some people are truth seekers. Like, we're like truth seekers. It's how we arrived at this incontrovertible, realization that the earth is indeed seemingly like plane more likely than it is a sphere. What did he say? How did he put it? Oh yeah, we're truth seekers. You guys are truth thumpers. You guys are fundamentalist zealots who believe yourselves to have the supreme truth of things in the universe. And you're just going to thump that. And you're just going to hold on to that with this zeal of like I said, fundamentalist religious zealot of any order. And it's the same thing. You guys just make it look sciencey and dress it up in, you're science adjacent. So it's like touching on scientific topics, look, when Maxwell saw, there was a contraction in the conductive materials as they ran these high currents through, and he's got these contraction equations. What if I contract space like that? What if I just borrow that and contract the reference frame to explain away Michael Zamorli? Like, okay, you can do that crazy shit if you. Well, come on, bro. It's just imagination.
Man, your man left. Dude Hanson just tipped out, bro. God damn. What you do?
John tapped out too.
John don't want no smoke.
Oh, Jaja back. What's up? Jaja, Yaya? I'm not sure.
I'm good, man. How you doing?
Pretty good, man. You stepped out on us the other day, yesterday. Real fast.
Oh, did I? Maybe I did. Maybe. Yeah. I mean, does it really matter? Does it really have much of a bearing in your ordinary life whether the earth is flat or round, right? Maybe we may have to take that position of the earth is not flat and the earth is not round. The earth is fucked. Maybe that might be a better position to take.
Chad. Yeah, I think we would all probably, it depends. I don't want to just outright say the earth is fucked up. Human society is in a pretty fucked up place. The earth will be doing fine, no matter what we do. Our in arrangements and priorities and like allocation of resources and energies are all fucked up. That's fucked up. But the earth is pretty dope still, kind of doing what it does. But I think that if there is any truth value to what we are, kind of poking at here, then it's really worth investigating, because if this could indeed be the case that humanity at large is being misled about the very nature of the place we inhabit and exist in and the reality of it, well then whoever could pull off a deception that big would have to be like the fucking wizard behind the curtain, right? If there was such a thing, right? If there really was some inordinately powerful group or cabal or something like this, then this would lead us to it, right? You pull at this thread, you absolutely see who's behind the curtain, right? And whoever it is, if the world is arranged in such a way that there's this elite group who kind of socially engineered the rest of us, well then it seems like they don't seem to have our best interest in mind, do they? You look at the trends of society and humanity and everything, like it's all filth and smut and garbage and inflation and more taxation and more neo-feudalism. So it's like maybe this may be a worth, because I don't think there's a conversation going or a thing you could pay attention to that's more that could be a faster catalyst for ending the status quo than this conversation. I think this is the one. This is the big one, because if indeed it's found out that the earth seems to be flat, well then someone fucking knows that. A lot of people know that, right? A lot of powerful people, right, who run industries and stuff, they know that. And and they're keeping that from people, and they're putting on a charade of a bunch of shit like space travel, and they keep us thinking that we live in a place and in a world of reality that we don't. And the question would be why, right? Why would they do that? Right? So that's all very confounding, and its scope and its scale is just so mind-bendingly large and crazy to consider, right? So don't start there, because that'll check you at the door. What you need to start at is the scientific, physical claims of, like, is the Earth curving or not, and what evidence do we have to support whether it's curving or not. And the flat earthers seem to have a ridiculous repository of evidence to suggest that bodies of water especially are not curving, which is actually a rather intuitive thought if you think about it, right? If you just suspend your disbelief for a second, like, you've never seen a body of water curve on the surface. So it's kind of a reasonable default null position to assume, hey, that surface of that water is not curving. But we're told that level water on a globe Earth is curving at a rate of 8 inches per mile squared. So this is what we're looking at. Is that actually happening on Earth? And it doesn't seem like that's what's happening. So that's what grown adults are sitting around and discussing. And the only reason we're having this conversation is because of the democratization of technology and optics. We can now see way further. Look at this beautiful dove walking by my window. Yeah, we can see further than we ever could before. The layperson on the ground. So, like, it's not up to scientists and experts so much anymore, right? If we can all just pull out a little rinky-dink piece of technology and look and confirm for ourselves that, hey, that shoreline over there should be around the curve, and there it is. I see people walking on it. What's going on? You know, and then you can snap out of the matrix, and we can figure out what the fuck is really going on. Why is the world so fucked? We got all this technology. We can talk to each other. We got all this. You know, why is it? It seemed like it's kind of contrived, like it's being purposefully fucked, right? That doesn't seem like these are the people's interest or best will, or, you know, especially in societies that call themselves democracy. Like, look at this. And again, what's causing the fucked up world? It's the same experts you guys defer to. At the root of every fucked up status quo and situation in society, from the poisons in the food to the wars, and it's a bunch of credentialed expert people fucking up the world. And you keep deferring to them, and they sell a bunch of fairy tales and nonsense because they can. Because that's how power works.
Who is they? When you're referring to they, who do you mean?
Depends on what I'm saying they and which sentence I'm saying they. But if we're talking about who could be putting on the deception as far as the Earth being a globe.
No, who is they? Who is actually they?
So I'm wondering what sentence, what context did you hear me say they in? Exactly.
So
they is just a pronoun.
Something as they or not?
Hold
they
on.
is just a pronoun.
A lot of people aren't like that are anti-free thinkers or don't question things have been asking that question lately. Who are they? And a lot of these people are adults. And right? You've lived long enough to understand. Hold on. Yeah, a lot of people who ask who are they are adults. You've lived long enough to see that there are a group of people that actually control all of this. So is it
adults? They are adults asking, or who's this they?
Well, here's the thing. Here's my thing about the hypocrisy of it all, right? When it comes time to talk about these fucking not elusive, but just the sort of metaphorical or proverbial expert that just exists in your mind, right? You say they loosely, without defining ever who they are, right? Or actually confirming the claims that you make about them. You guys just throw they out way worse than we do on our side, right? It's perfectly suitable to just throw out this general they. They've measured the sun at 93 million. You never ask who's the they or what the fuck on that side of the science.
Who is us and who is they? Who is us? What is this group that you are saying that us? Who is this us group? And who's this they group?
Oh, well, it would be people who buy into the globe Earth cosmology and people who understand.
So everybody believes in what flat Earth is us, and anybody doesn't believe in the flat Earth.
In the context of that specific sentence, yeah, man, that's how I use it. These are pronouns. You know, you use them sometimes. They have meaning, and that was
just to clarify, like, what do you mean
it's
by
not perpetual us? That's not some rigid.
So what you're saying
that's
that
not some rigid category, bro. That's not some rigid category. That's just what I use.
They gave us the information to talk about. That's the they. The people that's in control. They. Them. That's the they we're talking about. The people that's in control. The people that's in control of the information.
Okay. Let's define who is in control. Is the scientist?
all that shit,
Is
bro.
the scientists
There's been a day
control?
in this conversation forever, bro. Like it's not that hard to really. You know what I mean?
Scientists, the
we can't give you a
scientists.
name of who they are, but the bigger part of this conversation, bro, you guys refer to a group of scientists, right? When we ask for
What do you mean,
experiments,
you guys? Like, I
you
don't
guys
belong
just say,
to
well, the
any
scientists
group.
have measured it, right? And you kind of refer to a they.
What do you mean,
You
like,
don't have
you
a name,
guys?
you
Like,
just
I
have
don't
an
belong to any
experiment.
group.
When we ask for evidence of space travel, you say they, it's NASA, right? All the space agencies. Why would they lie, right? And so there's a they on your side of the conversation that you appeal to as well. And we're just saying that these people that you're appealing to that are claiming they've been to space could be fraudulently giving us bullshit, right? And you're just ignoring it.
Yeah, but just define this, who these people are. They
The heads of listen, are you listening? It's very simple, bro. It's very simple. The heads of the major states and corporations and industries and armies of the world, man, it would be them. It'd be them.
Okay, so we'll just say that government is they, yeah?
It doesn't necessarily
And
mean the government.
scientific authorities that are upheld by governments as well.
And it doesn't just have to be government. If you look at how the American... Listen, hold on real quick. Let me answer you, John. You can't be asking questions and doing the most talking if you're...
I'm just curious, yeah.
I got you. Just hold your say. Don't rapid fire the questions. You know, try to satisfy the answers, right? So, like I said, you said government, but it isn't necessarily government. That would be kind of like an oversimplification, right? And this is kind of tactical how people do that, right? Because look at how government works in America. The lobby and the interest groups really control it, right? So the government people in the front, they may not be the ones necessarily the masterminds behind it. They're catalysts and they're pawns in it, but so it's not necessarily just government, but definitely you would say the heads of the state follow the money, follow the power, you know what I mean? Follow que bono, right? So it is an interesting question who it is, who benefits and who they are. But that would take us back to the beginning of the fucking narrative of the earth being a globe and the model, right? It's always an imperialistic group regime of colonists, right, who plan on taking people over. And so they use this idea as part of it.
So is it just the colonists or any government in the world are they?
Well, it just so happened historically to have been the European colonists, right? And it was really headed up by the Vatican, right? And it was the same year that they put out these papal bulls to go out and colonize and conquer and imperialize the rest of the world. It's the same year the globe model came out.
All right, so
it all happened in one fell swoop. It's kind of a coincidence.
Right. Don't you think that, okay, so you would say the Vatican is they?
The Vatican is definitely a big part of the they, yeah. There's the elements inside the Vatican, more specifically the Jesuit order of the Vatican, right? They are really the main culprits, I would say.
So the religious order, you would say they?
Yeah. It's not really religious. I wouldn't categorize it as religious so much as I would philosophical.
Chicago cheeseburger.
So, okay, the Vatican, right? That's a religious order.
No, it's not the
right?
Vatican. It would be the Jesuits. The Jesuits. Let's call them the Jesuits.
So, okay, so it's not the Catholics then. It's just the Jesuits.
They're not secular. They don't buy into religion. They're into some other shit. They have a religious facade. They're not into religion.
So it would be, okay, they would be the British government, right, at the
that's
time.
not the British government. But yeah, the British government does put, the British Royal Society, all of these. There's a bunch of different fraternities with different charters who all contribute to this bigger idea that is definitely, I would say, centralized and headed up by the Vatican historically. I would agree to that.
Okay. When you say Vatican, you mean the Catholic Church?
Sure.
Overall, what you guys are saying, in my humble opinion, and I'm
so it would be the Catholic Church.
Because as we do,
it would be the monarchy from England.
You got to understand, like I just mentioned, similar to how in America, right, you may get a talking head saying, yes, we need blah 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 blah, but his pockets are being lined, or there may be a gun to the back of his head by the actual interest, the actual person and purveyor of the deception or the scheme or the conspiracy, right? Do you get that part? So it may not stop right there. So it's a little myopic.
You seem to know that.
You also from Givat Chaim?
No. When I am so much don't like somebody as I don't like Shuki, I lie some lies, but everybody knows that I lie.
Okay.
So you're not the first one I said that you told me that you make a suicide.
Damn.
Half of the people in the room, say the same about them. Don't have to take so serious every word and not take the virtual life seriously.
Yeah, but that's like a really bad thing. Like, you could get someone in a lot of trouble. Like, imagine if Shooky believed you and that we had that conversation.
Yael, מה נשמע, Yael? What's up?
Shalom, what's up?
Voila. All good, all good. So where are the energies? Where are the energies before the Passover here? I don't hear any energies. I only hear Shuki, Amos, Shuki, Amos, Shuki, Amos.
I think it's time to sing for
Amos ya ben zona, Amos ya ben sharmuta. Sorry, I had to. Sorry,
man. Linda, who's here? Linda, I have a surprise for you. Do you know who's here next to me?
Yeah.
Opa!
Hello! Hey, Bob! It's funny that you already know me when I never entered this app.
How are you, Nir? מה שלומך?
בסדר.